In this workshop, we have many good papers that discuss about AI and democracy in general. So I'd like to enjoy the whole day. Thank you very much.
Yeah. So we can also this one. Sure. Yeah. So welcome everyone to Montreal and Democracy in AI workshops. As Professor Ito says, this is our 6th version of a workshop. So we started it, I think, back in 2019 with Amos. It was different workshops like agent, and then we started back with PDCAI and then IJCAI. These are the workshops chairs. So this is me and Professor Rafiq. Actually, his flight has been canceled. Maybe he's joining on August 5th, 20. Professor Takayuki Ito, our lead, and Professor Anastasia from Estonia. So the program overview of this workshop, we received 13 submissions from 9 countries. 5 regular paper has been accepted. And we have 4 extended abstract, 4 lightning talks, and we have overall 5 sessions and 2 invited keynote speakers. So these are the submission we received from Europe, Asia, Oceania, and North America. So it makes sense that it's international. And also, as we said, we have 2 invited talks. Professor Maher, she unfortunately cannot join us in person due to some circumstances, and she's online. Will deliver her talk using Zoom. And we have the second speaker, Professor Maher is from University of North Carolina at Charlotte, United States. So we have the second keynote speaker, Professor Michael from University of Toronto. His talk is afternoon sessions. So this is a Professor Maher QR code. So for someone who want to, but actually, so I make it because I wonder if the sound work or not. So I think we don't need it. So this is program committee consisted of 15 international researchers from different countries. And special thanks to our reviewers. We have received their contribution made us success. So we really acknowledge and appreciate their effort. And so today from 7:40, we will have closing remarks and award presentations. So we have 4 types of awards, like Best Paper Award, Best Extended Abstract Award, Best Presentation Award, and Best Student Paper Award. So the award, the winner will be announced during the award ceremony. So we will ask the corresponding authors to please join us. And also, we want to announce that the proceeding of this workshop will be published by Springer. So we would like to remind that we also received the camera-ready paper versions, but we also remind and request the authors to please submit your paper according to the preceding format, which is Springer Computer Science. So please check it. You have time by August 28. Please submit, and then we will have 8 more weeks to online. It will be online. So and also another call. We also have 2 other workshops and conferences. We have IEEE ICA as an international agentic AI conference. It will be held in China. We have a session there here, Democracy in AI. Also, we will have another Democracy in AI workshop in New Zealand. So if you have a time and interest, please consider it. So that's all. Thank you so much. So now I give the floor to Professor Maher to share her screen, and I will make a introduction of her and her talk. So let me, Professor Mari, can you hear us?
Yes, I can hear you.
Okay,
Are you ready for me to share my screen?
Could you please proceed? Go ahead.
Okay, it tells me that you need to stop sharing first.
Okay, so the it doesn't, to me,
maybe we just go to Zoom, like Zoom. Here, Zoom.
is kind of
Weird. Yeah. Let's go back to Zoom.
Zoom. Maybe. So, and show.
You have go to Zoom.
Yeah,
And you
no,
should.
this is the Zoom.
Oh, okay. Where's the other screen? Do you have? How do you go to the other screen? No. Go to the right, maybe.
This one is.
No.
Stop share.
All right.
Yeah, sorry for technical problem. So yeah, could you please go ahead? Okay, so we have more 3 minutes. Let me introduce Professor Mari. Okay, so Professor Mari Maher, professor of from University of North Carolina, is the director of Research Community Initiative at Computing Research Associations. In this role, she leads the Computing Community Consortium in research visioning activities. Notable reports include Future of Information Retrieval Research in the Age of Generative AI, CCCCC Workshop Report, the Future Research on Social Technologies, Communities-Driven Approaches to Research and Technology in Society. Dr. Maher also leads the Level Up AI Hub at CRA to develop consensus and resources for increasing capacity for AI education. Dr. Maher joined CRA after 13 years as a professor in the College of Computing and Informatics at UNC Charlotte. She has held appointment at Carnegie Mellon University, MIT, Columbia University, United States National Science Foundation, the University of Maryland, and the University of Sydney. Her research focused on artificial intelligence, human-computer interaction, and computer science educations. Her recent research areas include AI-based models of novelty and surprise, evaluating ideation and human-AI co-creativity, human-created AI interaction design, AI literacy, and personalized learning systems that encourage curiosity. She has authored over 300 publications with an index of 63, over 14,000 citations, and I-10 of more than 235 using the result from Google Scholar in 2025. So yeah, so please join me to welcome Professor Mari to deliver her talk titled The Imperative for AI Literacy. First, I met Professor Mari in IJCAI conference in Macau. So she was the keynote speaker and main conference. So today, she accepted our invitations to deliver to our workshops, to deliver and share her experience with us. Please join me to welcome Professor Mari, and thank you very much for joining us. Yes.
Okay, thank you very much for that introduction. And thank you for inviting me. I know when I spoke at Macau at IJCAI, I spoke about my research on computational creativity. And when I get to the end of this talk, I'll tell you how that's relevant to the talk I'm going to give here, which is on the imperative of AI literacy. I'm very pleased to be able to present this to a workshop of academics who are very interested in democracy and AI, because I really believe and hope I can convince you that AI literacy is absolutely foundational and essential if we're going to have a democracy anywhere in the age of AI. So here's my outline. I wanted to start by talking about why AI literacy now. AI has been around since the 50s. Why do we need AI literacy now? And many of these things, you're living in the world now. You probably don't need to be told why now, but I want to tell you anyway, because I think it broadens the conversation to help us understand why AI literacy is required, both by people who are in the field of AI and who are not in the field of AI. I'm going to pause for a minute to see if there's a problem with the presentation. I see everybody staring at the screen. Everything okay?
Yes.
Oh, good. I'll then talk about AI ecosystems, because understanding the importance of AI literacy is premised by understanding the role that identity plays in the AI ecosystem. So that is sort of part of the imperative. And then I'll talk about what is AI literacy. I mean, it could mean many things to many people. So I wanted to put my position in here and what we believe AI literacy is. I will also talk about the concept of AI readiness, which is a way of characterizing and measuring how ready countries are, how ready higher education institutions are, how ready is the public. I'm going to finish with a discussion. So I'm hoping afterward we'll have some time to have a conversation, not just a question and answer. If you do want to ask a question as we are going along, just make sure you indicate that in a way to me other than chat, because I'm not looking at the chat window. So let's get started. Why AI literacy now? When you look at the recent books that have been published on AI, you'll see a trend that goes beyond just the AI technology itself. We used to see books about what AI is, how it works, and what applications you'd see out there. And recently, we've been seeing books like The Alignment Problem, like Privacy and Context, like Artificial Unintelligence. There's so many books that have come out recently with this topic shifting from how does AI work to what is AI doing in our world. However, not many people read full books anymore. So most people are getting their understanding about AI from the news. And you can see headlines. ChatGPT may be eroding critical thinking skills, according to MIT. Hundreds of students penalized for using AI tools to cheat. Now, when a large percentage of the people, including computer science professors, are getting their understanding about AI and its impact on the world through the news, rather than through peer-reviewed, critical data and evidence-based books, we begin to see that we need something to balance that source of information with a more reputable and more comprehensive approach to education. Another imperative for AI literacy is in industry, and the data that you see here is based on information I received last week. I was at a Google consortium in San Diego on the integration of Gen AI into teaching the core courses in a computer science degree. And so this does focus on coding, but that is a large part of what computer science students learn about. That they noticed through surveys in the fourth quarter of 2024, 25% of the new code generated at Google was generated by AI, not humans. And so now in May 2025, they released and started the use of their Cider agentic tool. It's an internal tool for Google. 50% of their engineers leverage it weekly. And you remember when AI or early versions of AI did code completion, where you would start a statement and it would finish it? Similar to when you use email, and the email client has some sentence completion tools behind it, and it would complete your sentence. It's far beyond simple code completion right now. And they've also noticed an increase in what they call coding velocity, which leads to all sorts of concerns that maybe we don't need as many computer scientists, companies don't need as many programmers, which is a problem that we shouldn't just accept and worry about, but think about what kind of skills do programmers and coders need. And so now there's a new mandate inside Google that leadership expects AI tool integration. It's no longer an option. They expect you to do it. They're shifting their focus from headcount growth to AI-driven productivity and efficiency. Let's unpack that for a minute. It used to be that the ability for a company to produce products depended on headcount. They hired more people to produce more products. And instead, they're focusing on AI-driven productivity and efficiency, and that their new job postings require AI and machine learning skills. This is a big shift, and it's a very fast shift. And when we talk about AI literacy, we talk about a lag, that we have huge changes happening in industry, a lag in our education. So this is the Digital Education Council. They did a report on what's happening with employers in the workforce. 51% expect new graduates to be proficient, not just know about tools, to be proficient. They're also 53% are worried about their graduates' ability to critically evaluate and build upon AI-generated content. So it's gone beyond just their ability to use the tools, but their ability to be critical in their use. They say there's a huge lack of preparation for this transition, and the transition happened very quickly. Only 3% of employers believe that institutions are preparing graduates for an AI-driven workforce. 80% of employers feel higher education is not keeping up. And then this last one is really interesting. Most valued skills by employers in the workforce. 92% believe the most valued skill is critical and analytical thinking. Where's that in our education? 62% believe that the ability to work with AI is the most valued skill. And this is in comparison to domain expertise. Only 19% think domain expertise is the most valued skill. So what are the benefits of AI literacy? Now let's step back and think about AI literacy for all. I'm going to, as we go forward, I'll unpack that a little bit. What does it mean in higher education? But more generally, what does it mean for all? First of all, we need to be able to empower individuals in understanding how it works and use them effectively. And I want to point out, and you'll hear me say this a few more times, use them. The skills to use AI is insufficient to empower individuals. Having them practice and use ChatGPT does not empower them. We believe they need to understand how it works. Now, some people say, yeah, but we've seen with other technological advances that understanding how it works is not important. For example, you can learn to drive a car. You can be an excellent driver without knowing how your car works. However, AI is not like your car. AI is interacting with you to affect the way you think, to affect the decisions that you make, and to filter the information you have access to. And so, because it plays an integral role in our decision making and our thinking, understanding how it generated that content is critically important for you to be able to understand how it got there, where there might be issues, how you can critically engage with the AI. You don't really critically engage with your car, even if it has self-driving features. And so that analogy doesn't work with AI. Promoting, in order for us to have critical thinking, we do need to emphasize that people should not blindly trust AI output, that they need to understand enough to analyze, question, and verify the information, even if it means interacting further with the AI. Fostering ethical and responsible use is a benefit of AI literacy because once someone is AI literate, we're more likely to ensure that AI systems are used in ways that align with human values and don't perpetuate and amplify societal biases. And then finally, this bridging the digital divide. The digital divide is actually not finished or closed. We still have the digital divide. However, the AI divide is becoming a really very real problem, both for individuals as well as for countries, as well as for governments, industry. Those that do not have access to or a broad and deep understanding of AI risk being in the have-nots of AI. And those that have the privilege and the opportunity to become AI literate are the haves. And we're seeing this gap broaden, and we're even seeing that some people who are in the computer science field fall on that side of not understanding AI. It's not their area of specialty, so they do not have the AI literacy needed to critically determine and evaluate a new curriculum. So this is a workshop on democracy. And while I've worked with sociologists and philosophers before on AI policy, I'm really only an observer when it comes to what are the threats to democracy. And I brought up three of them, and I'll go through them, but I want you to appreciate that the threats that are being given to us, I did a Gemini prompt on this, but looking at the news, the threats that we're seeing are technological. So the amplification of misinformation. We now see that AI can generate deep fakes. We can now mass produce false narratives. We can use these to suppress turnout for voting. These are serious problems as the technology continues to become more capable. It's very difficult to detect a deep fake. We have potential now with AI and the reality of targeted manipulation and micro-targeting. And this undermines the idea of a shared public sphere and a collective civic conversation. And then finally, the third top threat is the bias in algorithmic governance, that AI is actually, not just can, perpetuate and amplify existing social inequalities. It's leading to a loss of public trust and government impartiality. I just want to think for a minute. These threats are because the technology has become so advanced that it can be used for bad by people who are not AI professionals. What does that mean? It means we're really good at our job. We produced amazing AI. But it means that we didn't take into account that these threats can be mediated and need to be mediated by the people who are and the people who are not the AI professionals. There's nothing in these threats that says an uneducated public is a threat. A public that does not have AI literacy is a threat. And so I'm wondering why that didn't come up when you do a search. Why didn't it say AI literacy or lack of literacy is a threat to democracy? However, AI can address these threats. In developing critical media literacy, people can begin to recognize and understand the media that's being AI generated. A more AI literate public can demand transparency and accountability. And it also fosters a more inclusive dialogue. If you have widespread AI literacy, you ensure a more diverse range of perspectives that are heard. Even the people whose job it is to regulate AI lack AI literacy, and they are defining the policy. Now, how do I know that? Because I'm not sitting on government policy committees. In my own organization, I work for a nonprofit, the Computing Research Association, and they tasked me with developing the AI policy for the nonprofit. We are a computing research association, and there was a lack of AI literacy in our company to appreciate and understand first, why did we need a policy and what should be in it? And so one step towards developing policy is AI literacy. Okay, so there's the imperative from the perspective of industry, governments, democracy. Now I want to amplify that imperative by looking at AI ecosystem frameworks and their inclusion or lack of human identity in characterizing that framework. If we don't have human identity in those frameworks, then we run the risk of the AI divide getting greater, and we run the risk of AI literacy missing one of the most important parts, that it's our identity that matters, not just the technology. So this is the human AI ecosystem framework that we developed at UNC Charlotte, myself and my collaborator, Yash Tadamala. I'll introduce him soon. But what it does is it takes this inverted pyramid where the AI creators are at the bottom and the AI users and consumers are at the top. And it characterizes how our human identity and the way we characterize it here is much broader than just gender and race, which is what most government policy uses to characterize our identity, and includes all sorts of factors that affect our identity, our sense of belonging and inclusion. It affects the way we interact with and experience technology. It also, if you look at that creators, blue bottom of the pyramid, affects our access to be creators. And because of that, those creators in that small blue part have an impact on what's created. They have an impact on the consequences and considerations, and they have an impact on the users. So you might take creators on the order of thousands, having impact on users and consumers on the order of billions. And so looking at the framework from this perspective allows us to have a lens on that left-hand side for studying impact, who has access. And when we look at users and consumers, what is their perception of AI based on their identity? Do rich people, well-educated people, have a different perception of AI than someone who is less educated and maybe less educated and less wealthy? And then the impact is enormous. On the right-hand side, we've identified constructs for studying impact, and these will look very familiar to you, the idea of sense of belonging, bias in the data, fairness, diversity, accountability. So this is the ecosystem framework that we've developed and we've published, and we're starting to do studies that use this framework to allow us to study specific paths through the framework. Now let's stop and look at the industry perspective. What do they say an AI ecosystem is? Well, broadly, the industry term AI ecosystem is a network of interconnected stakeholders, technologies, services, and resources involved in the development, deployment, commercialization, and governance of artificial intelligence systems. You'll notice that their AI ecosystem doesn't include people. It must implicitly. But when they look at their ecosystem and the health of their ecosystem, it does not include people. And it doesn't include, well, if there's no people, there's no identity, no way of distinguishing between the differences that people's identity brings to the AI ecosystem. One of the things we also noticed in a lot of the studies we read about AI users is they don't even collect identity characteristics, unless maybe it's gender or maybe it's race, but they don't collect any of the other markers of identity. But there is a movement called Human-Centered AI, and they produce frameworks. And this one is an early framework proposed by Ben Schneiderman called Human-Centered AI, where this framework does talk about human values, individual goals, design aspirations. It does cover the stakeholders and the threats. But when they talk about human-centered AI, they do focus on the human as user. And in the framework that we presented, we focus as strongly on the human as creator. So who are these creators and what are their identities? Well, we know who they are. The creators and producers of AI are in layer one, that little blue wedge at the bottom. It includes the engineers and the developers. It includes students. They are the developers that sometimes end up being producers as students through entrepreneurial efforts, but they also are the pathway to become the engineers and developers. So their identities are critically important, because if we don't have a broad range of identity in our students, we can't have a broad range of identities in our engineers and developers. And then we look at researchers, scientists. Let's just look at the bottom right, government and policy institutions. What's the identity of the people in those institutions? Are they representative? Are they bringing the different experiences that different identities have to the creation, the policy of AI? So this is huge and complicated, but I do want to emphasize that this framework dives deeper than just those high-level concepts. It shows the creators, again, that blue wedge at the bottom, as layer one, and it moves all the way up to the users and consumers and indicates what is there, like I did for the creators. What is it that identity has an impact on at the creator level? At the creation infrastructure level, what role does identity play in data that we collect? Now, we know very well that the data collected to train our large language models is biased. So clearly identity has a role. I'm not going to go through all of this, but to say that it exists and it provides a way of looking at the research that you're doing or the topic that you're discussing and drawing a path from layer one to layer four to see where you are in this framework and what lenses and what constructs help you evaluate the role of identity in that particular path through the ecosystem. And now stepping back just to look at it from a bigger perspective, we've identified the concept of a boundary object. But if you look at the wedge now, which is in the center of this diagram, and that blue at the bottom being the creators and the yellow at the top being the users and consumers in the application level, we can see that the creators of AI on the left, these people are more nuanced in their identity than just identifying their gender, their level of education. There are many other things that have an impact on their contribution and on the creations and the consequences on the consumers and the users. And at the top, you see that the characteristics of these creators, their value system, their ethical considerations are what pours into that AI ecosystem. And if you look at the consumers, it's their individual perception, the societal impact, and the cultural narratives and norms that affect their perception and attitudes towards this AI ecosystem. So those are all the imperatives of why AI literacy is critically important today and essential as we move forward and develop even more powerful AI technologies. As we think about AI and democracy, is it a technical problem or is it a socio-technical problem? And so in AI literacy, we look at the difference between traditional AI education, which provides the basis, the knowledge, and the skills for looking at AI in democracy. And we look at traditional AI education, which has, AI history and concepts. It includes technical knowledge and skills, basically prepares people to be AI developers, or at least knowledgeable AI users. And then we look at socio-technical AI literacy, where on the right-hand side, we have a box that says it includes AI use, ethics, impact, policy. A lot of AI literacy courses have that box. We propose that AI literacy needs to also include traditional AI education content, which are the two boxes on the left. Now, obviously, you can't have everyone have the scope and the depth of a traditional AI education in their AI literacy course. So it depends on who you are as to what components of AI literacy make sense for you or are packaged for you to understand and apply. I also want to compare AI literacy with prompt engineering because for many people, when they are told they need to know about AI, they're sent off to take a prompt engineering course. And so it's important to distinguish between AI literacy and prompt engineering. Prompt engineering is the process of crafting effective instructions or prompts so that you can get AI output that is desired, that you minimize so-called hallucinations, that you have the ability to critically interact with and understand the output. However, prompt engineering is not sufficient. It was interesting last week at the Google Generative AI and Computer Science Education Consortium, there was a strong focus on the skills needed to interact with AI through prompt engineering in order to ensure that students are using generative AI to learn about coding and to produce higher quality code than they could if they didn't have the AI. However, there was nothing in their scope to say that before you learn how to prompt, you need to know some technical knowledge about AI. How does it work? You need skills. Prompt engineering is a skill. You need to understand the attitudes that people bring to AI, and you need to understand the social awareness. So again, AI literacy versus prompt engineering shows that AI literacy should be the focus, and prompt engineering is one component of it. So we've defined 4 pillars of AI literacy. One is the understanding the scope and technical dimensions of AI. The second pillar, how to interact with AI technologies. And in the courses that we've talked, we have focused on generative AI technologies, but they need not focus on that. There's a lot of AI out there that is not generative AI. They need to be able to apply the principles of critical, ethical, responsible AI usage. So pillar 3 is about the individual. And they need to be able to analyze the implications of AI on society. And so that brings AI into the broader scope of what is its potential impact on society, and how can AI literate individuals be more prepared, both to be in that society, but also to shape it. I'm going to just unpack these a little bit and explain for each of those 4 pillars, what sort of things do we teach? Why do we think these are important? But the depth and scope and depth and breadth of what goes in this first pillar depends on whether it's AI literacy for middle school, or it's AI literacy for computer science majors, or it's AI literacy for the non-major in higher education, AI literacy for government employees. And so keep in mind that this is defining the broad scope. We have developed the curriculum in depth so that each of these has 3 or 4 modules in them. And we've developed in one of our publications where we think the emphasis should be for each of those subpopulations who are engaging in AI literacy education. So first, what is AI and what is machine learning? Because AI is bigger than machine learning. We also talk about how knowledge is represented in AI, where symbolic is about constructing the knowledge based on human understanding of knowledge, and deep learning constructs models, aka knowledge, from data. We are finding that the public no longer can tell the difference between a search engine and ChatGPT. And especially now as we have these retrieval augmented generation where the boundary is blurred. But if you're interacting with a generative AI that does not have a search engine behind it, then it has a larger potential to be biased and to be producing incorrect or so-called hallucinations. And so we find that if you don't understand the difference between a web search and a large language model, it's going to be really difficult for you to critically engage with an AI tool without knowing there's a difference. And then finally, how do large language models work? Now, coming back to, do you need to know how your car works to drive it? You need to know something here. You need to know that current large language models are basically using a prediction model, a transformer algorithm. What does that even mean? And you can unpack that without having courses in probability and without having courses in machine learning. You can unpack it in an intuitive way. So there's a understanding of the concepts without understanding the mathematics and the algorithms. In learning how to interact, you'll see that prompt engineering is there. There's also a huge issue on authorship, ownership, academic integrity. If I use AI to do homework, or if I use AI to produce a product for my employer, who owns it? And when have I gone too far in using AI to replace me in what I do rather than to augment me? Critically reviewing ethical and social responsibility. This is largely done through case studies at the moment, where we, rather than look at AI, responsible AI as a technical problem, we look at responsible AI as from the user's perspective. We also look at the technical issues associated with security, privacy, and ethics in AI. So they get both the use and the development of AI and the issues that affect socially responsible AI. And then finally, future implications. We do study those news articles and the public perception of AI and have broad discussions about what do they think about that? What do they think about in the future of work that employers are saying they're not going to employ any more computer science students? That what does that mean? What does it mean if the workforce is being predicted to shrink? And then we look at policy, accessibility, and on the right-hand side, AI for good. AI can be used for bad, as we talked about before with misinformation and micro-targeting voters. What does AI for good mean, and where is that space? And how can people get involved in promoting that over the use of AI for bad, or even recognizing the difference between AI for good and AI for evil? This is a busy slide again, and I guess what I wanted to do with this was point out the difference between the levels of understanding and the levels of knowing. This is Bloom's taxonomy on the left, where we, at the bottom of Bloom's taxonomy, we have this concept of remembering. And then we go through layers of knowledge from understanding, applying, analyzing, evaluating, and creating. It could be that AI literacy, like many training courses you might take in a university or employment situation, it's all about remembering. You watch some slides and you do some quizzes. If you get the right answer, you have that knowledge. That's actually not a good place for us to land, because we're getting to the point where students don't need to remember because they can get AI to tell them. And so as we're developing AI literacy, we're also developing their understanding of Bloom's taxonomy and the essential part that humans bring to any education or task. And that is that ability to analyze, apply, evaluate, and create in a critical way with AI literacy. And so here, I'm closing off this part of AI literacy and presenting it as core knowledge, that we think that AI literacy needs to be the core course in higher education, both for CS majors and non-CS majors. It may even, because of its socio-technical nature, it may also increase the diversity of people who choose AI as a profession, because their first introduction to AI doesn't require 2 to 3 years of mathematics and probability and statistics, because they can be inspired by the potential of AI before they learn the mechanics or the theory of AI. What this also shows is that you can extend each pillar beyond the basics of AI literacy and start to think about, well, pillar 1 is the starting point for becoming an AI engineer. But maybe pillar 4 is the foundation for becoming an informed AI consumer, an AI auditor, an AI ethicist. And so we can see that these different pillars in the core course provide the basis for other courses, other education. And this is where we've sort of pulled it out and dove in deep on what are people teaching at universities on AI, where the center is AI literacy. And as you move above AI literacy and off to the left, you get a much more highly technical AI education that builds on AI literacy. If you move to the bottom left, you look at a more creative interaction education, looking at human-robot interaction, co-creative AI. And if you move to the bottom right, you're looking at a socio-technical education about policy and law. And if you move to the top right, you're looking at AI systems education, because you're looking at both the technical and the implications. And so we see AI literacy as a starting point, not as an alternative to AI education, but as the starting point for AI education. Okay, I'm going to transition out of AI literacy. I've spoken for 40 minutes. I think I have about 10 more. I just want to introduce this concept of AI readiness. This is something that was produced by the United Nations Development Program, where they talk about AI readiness, which refers to a nation or an organization's ability to effectively implement and benefit from artificial intelligence. And they look at government as an enabler of AI and government as a user. And they also look at AI ethics. And they have ways of describing a nation's or an organization's readiness for AI. We look at Deloitte. This is industry's perspective on AI readiness. How ready is a particular company for AI? Where they look at the people. Are they ready? They look at processes. Is AI integrated? They look at ethics. What are their policies? Where is potential bias and integrity? And they look at data. Do they have the data to be able to integrate AI? And then technologies and platforms. And you'll notice in the AI readiness here, it is highly focused on the technology readiness. From those two frameworks and many surveys that have been deployed at universities to find out more about the use of AI in their university, we've developed a higher education AI readiness framework. And the stakeholders, well, first of all, AI readiness has to do with how is the university governance strategy affected? What are the policy and compliance issues, for example? Systems and infrastructure, how AI ready is the IT staff for AI integration and use cases? It looks at the bottom left, education, and you can see AI literacy is a component of that, but it isn't sufficient to assess the AI readiness framework. And then you look at the culture, trust, transparency, ethics, and responsible use. And so from this framework, we can look at the roles of those different stakeholders. For example, students as a subpopulation of stakeholders in higher education. We can see at the bottom that they now have access to AI for adaptive and personalized learning. That's the promise. Assuming, of course, AI literacy and assuming that the university gives them access. Because if it's only available for the students who can afford to pay for the AI, then you really aren't ready. You don't have readiness, AI readiness in your university. You're just propagating the AI divide. And then we look at the faculty. You know, for faculty, they have the potential to integrate AI into grading, content development, simulations, adaptive instruction. How are you going to get ready for that? How is it that faculty can be prepared when they're already too busy teaching too many courses, more interested in their research than their teaching? And we have the administrators. They actually, if you look at that bottom one, they direct the integration roadmaps. They define the organizational priorities. How ready are they for that? And then finally, IT staff. Are there enough IT staff that have enough knowledge of AI to do that? And then the academic, student, and business affairs staff. Those are all the people that work at a university who are not students, faculty, and leadership. And they are interacting with AI all the time. How can they evaluate or assess enterprise level use cases? How do they know what to do? I gave an AI literacy course to the faculty council at UNC Charlotte And I presented it as it needs to be a gen ed course. It needs to be a course that every student takes. And starting this fall, it is a gen ed course. It is a required course at UNC Charlotte. And what I heard from the people on the faculty council was that they needed AI literacy, not just the students. And so when we think about this readiness framework, we have different needs and different, I guess, metrics for assessing AI readiness. This is the result of one of the surveys that we did at UNC Charlotte, where we transformed each of these AI readiness factors: stakeholder engagement, AI literacy, talent development. And we collected data from the different stakeholders to look at where they were on the AI readiness. And we recognize that, for example, AI literacy probably should have reasonably high AI literacy for all stakeholders. But when you look at leadership and resourcing, some students do get involved in leadership, but not many. But you definitely need the administration and the leadership to be ready for that. So again, this AI readiness framework provides a basis for research on what it is, where we are on that readiness scale for AI in higher education, in industry, in government. Okay, that's the end of my slides. I have a few more slides I want to talk about before we start a discussion. One is, who are we? So I'm Mary Lou Maher. How did I get here? For 35 years, I've been doing research on building AI models that can demonstrate creative thinking and creativity. I've also been building systems that augment human creativity, so that human AI co-creativity. As part of that research, we did a study on how do human creators perceive the AI in terms of being trustworthy, ethical, ownership questions, and found that there was a huge variation and really a lack of understanding from the user's perspective on what they were interacting with and how to critically evaluate it. And so that was about 2021, 2020. And then along comes ChatGPT and the proliferation of large language models, which helped me transition into, I still do the co-creativity studies, but this AI literacy is actually really critical. And then I partnered with Yash. He was one of my PhD students. He was very interested in identity and how it affects their interaction with and whether they even choose to learn, to use, or develop technology. And sort of oriented him and pushed him towards this AI identity framework. He also serves on a few panels, the Technology Focal Point and the Youth Panel for the United Nations. So he does sit on a lot of international panels through the United Nations to hear about the policy level. And he's also part of the World Student Platform for Engineering Education and Development. He's been a really great resource and collaborator for bringing in that policy and government perspective. We've published a lot of papers, but most recently, AI Magazine, with two other AI professors, Dave Turetsky and Michael Wolowski, we put together a special issue on AI literacy and AI education in AI Magazine, and Yash and I published a paper there. We've published papers in various conferences. I've published with Ros Mikkelsen, who's a sociologist, and Gordon Hull, who's a philosopher. And what is our sort of our changes in need for a different kind of education for 21st century economy and society. And then finally, I I just wanted to say a little bit more about my current position. I am now a director at the Computing Research Association. I am also a professor emeritus at UNC Charlotte, so I continue my involvement there, but I'm full-time at CRA. I am the director of their CCC, which does visioning workshops. And this has funding from NSF. It's a cooperative agreement to not fund specific workshops, but to catalyze the research community to identify pressing topics that need a multidisciplinary perspective and to articulate new research visions. These are not next steps in your research, but what do we want in 5 years and how do we get there? And then we take those reports and we take them to government leaders, we take them to funding agencies. We participate in a lot of requests for information from the White House, from different congressional committees, from organizations like the DoD and NIST, and we call the community together to provide a voice for them to discuss and present important topics back to the government on the issues of the moment. So the executive orders on AI, the executive actions on AI, the congressional committees need to vote on a particular bill or law. They come to CCC for that. And there's a URL down here. If you want to propose a visioning workshop, which is not quite the same as a workshop at a conference, it's a workshop that takes about 6 months to plan. It's a workshop that we support not by giving you money, but by once you come up with your 50 to 60 people you want to attend, we fund everything. We fund their travel, their food, their hotel accommodation. We work with you for 6 months to plan and come up with a visioning workshop that follows our best practices for visioning. Okay, thank you very much. I want to open it up to questions and discussion. In summary, I talked about why AI literacy, the role of identity, and AI readiness.
Yes, thank you very much. On behalf of workshop organizers, I would like to thank you for your insightful presentation, particularly on AI literacy and how it should be essential for society. I think we also advocating the right for AI. I mean, like something like it should be like education is fundamental right of human beings. So it should be something like right to AI, not just like yeah. And your role for advocating such a initiative is acknowledged. We acknowledge that one, and so we will take some questions. We have 7 minutes. So yeah, if you have any question, please raise your hands and introduce yourself. Yeah, could you please come here? If you have any questions, please line up or sit. Yeah, just introduce yourself.
My name is Jeremy Wertheimer. I've been coming to IJCAI for about 40 years. Got my PhD at MIT in AI a long time ago. I've worked in industry at Google and startups and things like that. So I have one main question, which to me was kind of missing from all this in a way that is I don't know, surprising or troubling, which is I didn't hear you talk about incentives. And part of the problem is that we say things like, oh, look, let's use AI to teach people how to do better critical thinking. But that's not what people do normally. Or, you're saying things like, oh, look, the AI systems aren't marking the identity of people when companies are very strongly disincentivized about invading privacy enough to record things like people's identity. So I think part of the challenge is, how do you do this in the real world, in a research conference or among the AI?
See here to.
What would you like me to do?
She can see you.
Yes, okay. So how would you like me to talk into the microphone and be visible to the camera?
Yeah.
Yeah, so the question of incentives is a really interesting one. And if you think about where do incentives come from, right? So reward structures. In businesses, the reward structure or the incentive for AI literacy is that they produce better products with AI. As you can see with the data being collected, you actually get a better product if AI is integrated.
I'm sorry, I think you're looking at it the other way, which is the incentive for most AI companies, for most of the companies, whether it's OpenAI or Anthropic or Grok or Google or Microsoft, their incentive is usually aligned with getting more usage, right? Most of the business models align with usage. And so they're going to do things that are, if people want to repeat the activity, that's what they're going to, support in a reinforcement learning kind of way. And so if you basically tell people, here's something that you want, here's how you get more of it, then they'll do more of it. And these companies, mostly their financial incentives line up with usage. If you tell people, be a better person, something the person isn't doing anyway, something the university isn't doing anyway, something the school isn't doing anyway, and then you're asking them to, I'm missing the incentive structure. I mean, we haven't been teaching critical thinking to kids in school, for a long time. We haven't been, and so to me, it's like, I'm wondering why we expect the AIs to sort of bring out the better angels of the selves of people here without thinking cleverly about incentives, which is what people do when they want to get a lot of usage and want to change behavior, whether they're in business or in politics.
Yeah, I think that's a really good point, and probably not no answer, but a really important discussion. I mean, we could go along with what we have and increase the AI divide, but because that's what happens if there's no incentives for the critical thinking. You just get the people who have access to enough education and enough examples to be good at this. But coming back to democracy, what's the incentive for democracy? And is AI literacy somehow tied to that?
Sorry, I think Edward R. Murrow said it best. He said democracy is where people get what they want and they get it good and hard.
Yeah.
So I think the problem is if you want to have a different democracy, you have to train people differently.
Well, you have to have an educated public. Democracy doesn't work if you don't educate your public.
Right, but the problem is that what counts as education, right? Most political leaders, what they do for a living is they convince people to see things their way, right? They educate to follow them. And so if you want to advocate for a different perspective, you need to think about how do you try to educate people? How do you, basically to me, it's how do you think about what people want and how to align with that to get them to align with you, right? We see successful politicians figure out how to think of things that people want and align with those, not tell people what they should want.
Right.
Okay. So, yeah, do we have any other questions? So we have, I think, yeah, just 2 minutes. Yeah. Please introduce yourself.
Let me ask some questions, especially to the sector, companies and the public sector. What is the different point of view, public sector's AI and corporate AI? You mentioned a previous slide. I was very impressed that your public sector enables UNDP's framework. But are you much more comment? What you are thinking about that?
Yeah. So I think a lot of the work on AI literacy and AI readiness has been in the context of organizations, governments, and educational institutions. And you raise an important point, and that's the public. Where do they fit in all of this research, and where do they fit in terms of their participation in AI literacy and AI readiness? Well, first of all, most people in the public are engaged in some organizations, so you can get to them through that. But what do we want in an informed public? How do we measure that, and how do we affect change on that is really a difficult question. Where are our levers to impact how the public understands and uses AI responsibly?
Yeah.
So I guess I don't have an answer. Just have a lot of questions.
Yeah. Okay, so I have a just short questions. Actually, we are running out of the time. So who will be the governing body in order to develop this AI literacy? Is there any governing body like universities, like or NPO? Who should United Nations? Who will do that? And who will provide the budget?
Yeah, at the moment, we're seeing it happen in educational institutions. So we are seeing universities take this on. We're seeing organizations like teachai.org has put out an AI literacy framework. We've seen nonprofits like the Digital Education Council putting out AI literacy frameworks and curricula. We're seeing, I guess, Trump's AI action plan that said AI in every K through 12 school. And so I don't know, there's no funding, but there is an action item. So I think the literacy has to start with the people who do education in the first place, and then that gets integrated into the other sectors, the industry, the public, the government. But the government, I mean, how does any education work? There's got to be some government incentive. There's got to be some way for people to have access. And that's why democracy, government policy is really critical in this. It can't be done by universities alone.
Okay, so once again, thank you very much. On behalf of the workshop organizer, I would like to thank you for your insightful talk. And yeah.
Bye-bye. Thank you.
Okay, thank you. Okay, so we will start our sessions. Sorry. Oh, I cannot see. So the next speaker, the next speaker is myself. So yeah. So hi, good morning, everyone. My name is Jawad from Japan, Kyoto University. It is great honor to present at DemocrAI at IJCAI this year. So today I will talk about democratizing and enhancing student participation in online education with LLM-based agent. In this work, we explore a conservative use of GPT-4-based agent as a conversational agent to support student engagement and learning outcome and online education. We hope this provides some insight into how LLM-based methods can be used effectively for educational purposes and social good. Of course, this project was not done alone by myself. It's a collaborative effort with Dr. Sofia and Professor Takayuki Ito from Kyoto University. As we know that online learning has become an essential modality, especially in crisis context, it allows students to access lessons and resources remotely. With introduction of generative AI, it really helped improve student engagement and student content engagement. But there is a growing concern. There is a growing concern that if we engage with such technologies, there will be a dependency risk if AI access is removed. So the study shows that once you gave access to the students using GPT, and then we remove those access, the student who not access GPT, they outperform than those students who access GPT. So it means that it raising questions about how students should use AI in education. So we particularly address that. Can we use AI carefully and constructively to support learning, especially in constrained environment? So we examine a conservative use of GPT-based agent as a conversational agent to support post-lecture discussions in online educations. And our case study is Afghanistan. Unfortunately, Afghanistan are the only country where women are officially banned from accessing traditional education by the Taliban. And then the girls switched to online classes. But the problem with those online classes is that we have limited resources. For example, one teacher can use Zoom to deliver the lecture for 100 students, where there is a limited interaction between those students and the teacher. And the limited interactions, the research says, when there is a limited interactions among student interactions, that satisfaction and learning outcome decrease. So our study aims to investigate to support the student interaction and instructor-student interaction in those scenarios, which we can realize how important it should be as a tool to support the process. So we design and build using OpenAI GPT-4 model to design our chatbot. So we applied few-shot learning and structured prompting. What we used is an example of question-answer pair from the lectures, and we also use 17 human-authored facilitation messages. So we followed predefined post-lecture discussion guidelines based on 3 sub-phases during the post-lecture discussions, like controlled by time. Like the first phase of post-lecture discussion should be to engage student in key point generations, and then bridging theory with the practice, and then finally to conclude the lecture by the student and post-lecture interactive. And also we ensured constant quality and consistent quality and hallucination. We are controlled from adaptation using the human-authored facilitation. So by this, the generative AI behavior has been somehow controlled. So this is the main user interface where we deploy the chatbot. You can see that red one is a posted facilitated messages by GPT chatbot. You can see this is human predefined auto facilitation messages. So by this one, we wanted to somehow engage the students in line with the topic of lectures and in line with the guideline of post-lecture discussions led by the human teacher. So this is, we conducted a case study in using a recruitment agency where we hired the students, not subject, but real students. So as we say that the students, the female not, joining traditional classes. So that's why they've been online almost. But the male, they are allowed to go to the classes. So we use that local subject recruitment agency to hire the undergraduate computer science student from Afghanistan. We used a 2-day randomized control trade with 80 undergraduate students, equally divided by gender. So 2 groups control and treatment groups. Each conditions. So first, each group with the 40 students, and the teacher come using the Zoom to deliver the lecture for the 40 students. And then these 40 students, that in traditional way, the teacher going to interact with them in Zoom. But there's a limited interactions because the time is limited, just like 40 minutes, and the teacher cannot interact with all the students. What we done, that we assigned these 40 students in post-lecture discussions in 4 rooms. That is text-based discussion form. And we use control without AI and treatment with AI. And then finally, we ask them to score their learning outcomes, self-report survey. So we measure the discussion metrics by discussion logs, using discussion logs, and consider 4 metrics: number of posts, replies, word counts, and likes. We intentionally made the likes because like is the passive interactions among the students. The most active interaction is giving opinions, and interact actively is the number of posts, replies, and word counts. And in post-lecture interactions self-report survey, we used a 7-point like scale to quantify the learning outcome and their satisfactions. As you see, the day first, treatment group posted significantly more posting per student than control group. And all 3 metrics, the treatment group outperformed the control groups. But in the if you see, the control group outperformed the treatment groups. It means that in the control group, where there was no interactions, the students just tried to like each other without giving opinions. I think that it has some meaning. And also in the day 2, the day 1 replicated. So that's why the case 2 validated the case 1. And also the case 2, the day 2, also the like were student and control group outperforms in terms of just giving likes. I mean, so if we look this result from the combined result from day 1 and day 2, the findings were consistent, confirming the case 2 validated the case 1. So you can see the blue one is the control, and the orange one is the treatment one. The blue one, that in post-lecture discussions, there was limited interaction between the students because there was no presence of someone who lead the post-lecture discussions. There was only one teacher in 4 rooms. So at one time, 3 rooms, there were no teacher. But in control treatment groups, always there was a AI agent plus human teacher, but AI agent were always present. So this is the post-intervention survey. So we try to evaluate the ask the students the questions. Do you feel confident in this area of study? I mean, what the teacher gave you lecture during the Zoom, are you confident about what are the takeaways? So the student gave answers by 7 scale. So like strongly disagree, slightly disagree, neutral, slightly agree, and strongly agree. So here, the treatment group reported significantly higher confidence than control in their learning outcome. This was statistically significant. So an interesting observation in our study is that post and control group discussion without AI received more likes from peers of students than those in treatment groups. So what could be the interpretation of this finding? One possible explanation is bandwagon effect. So bandwagon says, what is visible to society, the society will follow that one. For example, if I be happy and behave like a good with you, you just do the same action with me. Or let's say if we have a WhatsApp groups, and if the group member just like, other people just like, or if that group actively posting, the other member also posting. So in a control group, because there was no one to lead the post-lecture interactions. So in the post-lecture interaction, there should be someone to lead, because almost all students not good to takeaways of lecture. So there should be someone to appeal what are the key inactive takeaways during the lecture. So that's why if somebody, you know, just try to contribute, other people just try to engage with that one. So by this, we realized that one of the application of chatbot which can be used for educational social good, not to just give access to GPT, give access to student to ChatGPT, but somehow to localize the usage of ChatGPT to the students. So GPT as a tool could be good when we try to define the usage of it. For example, it's like a knife. If you try to use it to cut apple, it's good, but other way it's not. But our study had some limitation, like small sample size. We just considered 80 students because of some resource limitations we considered. But we also conducted power analysis. It was the limited sample size we can recreate. And also a short duration. It was only 2 days. So we need to consider more, like 1 semester. Student with student with and without, and then also try to remove these method and then try to find out for 1 semester or 2 semester. And also limited generalizability. We just consider computer science undergraduate students. We have to consider other subjects like social science, like different level of students background. And also, the most important shortcoming our study is that we just relied on self-reported survey without follow-up testing and actual learning gains. Usually, we use teachers to evaluate the students, what they gained or not, if they are successful or not. But we just ask the students to report their learning outcomes. Usually, the students, you know, they are biased. When you say, I'm good at something, you might be biased because you might not be good at it. So there should be some independent body to evaluate. So maybe in the future, we try to use the same teacher or another independent committee to evaluate if the learning gain is good with the team or the students who use the GPT chatbot or not. And using all these combined approaches, we might consider a long-term study and then use these approaches. And then after that, then we can use the insight for informed policy making. So yeah, to summarize, LLM-based chatbots successfully supported post-lecture discussions. Post-lecture discussion is that the students try to engage with each other to share the takeaways, what the takeaways during the lecture. So we not use the during the lecture, we just use it during the post-lecture. So it showed that it increased student engagement and learning outcomes. And also it offered promise for use in low resource restricted settings like Afghanistan. Maybe the application of some tools might be not realizable in somewhere, but it might be realizable in somewhere. During the COVID, we understand the Zoom importance. But if there was no COVID, we might not realize the Zoom importance and applicability. So that's why in the future, we have to aim to run longer term studies, maybe 1 or 2 semesters, introduce objective testing of knowledge gains, use teacher or independent committee to evaluate the gain, and also explore multi-agent collaboration and personalized support. In this study, we just use one type of agent, where the aim was to engage with the student and to enhance their learning outcomes. But in the future, our lab already developed and designed some other role agent to play a role, like to try to support student with critical or difficult terms. There is some terms which use in the lectures where students cannot understand. So we use an agent to try to define and simplify those terms, or language translate, or some other functions which agent can play. So yeah, these are the citation of my work, and that's all. Thank you for your attention. Feel free to reach me if you have any questions. Yes, please.
Yes. I'm curious, did you observe the students responding to one another or mostly to the chatbot? Like did they respond to the chatbot and then another student responded on that? What was the pattern?
Yeah, that's very good questions. Actually, we have when we look, we just not consider we just consider replies, general replies, but replies also falls under the AI facilitated post. But we not mainly in this study to look how many percentage the replies are AI to AI, or it is student interaction, or it is student content interactions. So in the future, we will look the student interaction, student AI interaction, and student content, the lecture content interaction. So maybe we can make more graphs to provide the insight for this one. Thank you so much.
Thank you.
Yes, please.
Thank you for I understand perfectly the application for purely online setting, given really the Afghanistan.
Yes.
Very, very clear. But I wonder whether this kind of approach could be also adapted for physical classrooms and could be somehow a sort of reinforcement also for physical learning.
Yeah. Yeah, thank you very much for the question. Actually, we just realized the applicability of such initiative, but of course, and this is where the scalability, it's because of scalability. But in post-lecture discussion, if we have a class, literature says a teacher which is capable to lead a class of a size of 15 students, he cannot lead 20 students. But we can see, a teacher can, there's math problems, which the students, the class size is 50, 60, and there is no interactions between the student and teacher and student during the post-lecture discussions. Of course, such scenario should be realized, and we should use some AI as a supportive role with like using some avatar or something, a teacher assistant or something to maybe we should, but how to deploy it, because it is physical in person, we don't have any idea about now, like how to deploy it. And for example, right now, like we have in post-lecture discussion, how to deploy it, in what form we should deploy, because it is in person. And in person, usually the constraint is that there is one-to-many communication. Many to communication cannot be realized in person, right? So how to realize many-to-many communication in person, like in physical? That's like a challenges. Yeah. Yeah, that is a question. If we just come up with a solution, and then maybe we can deploy it. Thank you so much.
Channels.
Yeah, yeah, maybe. Yeah. So yeah, that was all. Yeah, do you have any?
Starting to look at post-lecture interaction.
Yes.
I'm just wondering, would you or have you considered actually developing a more personalized lecturing process? Because it strikes me that the materials you teach and the learning objectives are pretty well fixed.
Yeah.
But the variable in the learning process.
Yeah.
Who has different abilities to consume and process.
Yeah.
So understanding through that teaching interaction.
Yeah.
You can gear the materials more towards that person's ability to process and use it.
Yeah, actually, in the future, we aims to explore multi-agent collaboration and personalized support. So the personalized support here, like it is, we aim to explore the possibilities, how best we can lead to that direction. But that personalized, personalized the content based on the student attention, or personalized what that need more exploration. Need more literature review and then focus on, and based on that, try to, like you mean that we should have one-to-one agent for different students. So one agent cannot be deployed for many students. Yeah, that's very good directions. We need to check out with that direction, and if we can, how best we can go with that. Thank you so much. Yeah, thank you very much. Yeah, now we have a break, tea break, coffee break. So please feel free to serve yourself. And then we have after that, we have technical sessions. Yeah, thank you.
You remind me of some. Oh, you've got this Toronto behind the campsite. No, you look familiar with all the arrangements.
Everything work good?
Yeah, it's good. Like I have some problem with like when I try to connect with PowerPoint, and then there's of course it is like presenter view. I look at here, but sometimes I cannot. It is not visible to me from here to navigate some functions. So I have to go to main screen. So yeah, it is presenter view, but some function is not visible here. For example, I need to check here if it's proper or not, it's working. And then I realize something is missing, then I
No, sending.
maybe it's because of Mac, I think.
No, I don't think it's because of Mac. It's because you need to have the good transition of the mouse, like when it goes to through this edge, it goes through this edge.
Yeah.
And you have to know which edge it goes through. It took me a while to
Yeah.
like
Yeah, and another thing is when you plug, when you have all your windows open and you go to change the display, the information and the priorities are like in this part and the other output. So it's like
for example, to Professor Murray, I not shared my screen.
right now because
she was there.
you can't both share,
Yeah. I forgot to share.
And the remove share was at the top of that.
You
had to move the mouse to that screen.
For example, look here, look. So for example, look here. Yeah, now I share. Okay. So now look, from here I cannot see.
No, so you have to move the mouse.
Yeah, move the mouse.
And then it's now.
This is another extended
screen. Running the screen.
Extended screen.
Why this happening in this way? When you open one of the programs at the computer, and you don't have the output already in that when you open the program, it took the output as this screen, the main screen. So you can't control all the things at the same time as you want. So if you want to open that, you have to shut the Zoom right now.
Yes. Okay. So, 30 minutes.
Yes.
So
We have another.
we have more. So this is the first. We have second. Third, fourth. 30 minutes. Yeah, it's 30 minutes, and then like 25 minute talk and 5-minute question. Okay. So for each person, 25 minutes talk and 5 minutes Q&A. Okay. So first speaker, please.
Anyway, I can put it here.
Maybe.
Let me.
So, welcome everyone to my talk. My name is Víctor Abia Alonso, and I'm going to talk about value system aggregation. So, what we did in our paper is try to start introducing the conversation about value system aggregation because it's a topic that has a lot of connections with, oh, my bad, that has connections to well, decision making and also to value alignment. So first of all, we're gonna describe the problem, and then we're going to provide the guidelines to this problem, because it has been like understudied by the literature with just one proposal, and we're gonna like claim the importance of it. So first of all, value system aggregation is this idea of combining the values of different stakeholders into a consensus, into some consensus values that represent the collective. So as you see, we're going to have something that is combined into another thing. So probably like a function that takes different stakeholders, so different values, and outputs one value. And that this idea of value should be conserved. So they should have like a similar structure if we were to model them mathematically. So in this sense, the structure of the talk would be like present the problem, its relations to value alignment and to participatory budgets, and then start with the guidelines that we are providing in this talk. So for AI and democracy, value alignment is a core problem. So what is value alignment? Is try to in the case of AI value alignment, is try to make AI systems act in a way that aligns with the human moral values. So we have like, we want these values, the values of whatever person is, to be passed onto the machine or onto the computer. And so to get closer to this idea, let's imagine that we have like an AI assistant that is doing decision makings on a triage scenario. And triage determines how urgently patients should be treated at a hospital or whether they should go home. So we are going to make decisions of whether they should come in or not come into the hospital, guided by values. So, for example, you could deny like a patient a room because they are perhaps not gonna like live for long, so it may not be the best use of resources, but you will be denying them the right to care. So we want like a decision maker that has this idea in mind. But also, if you have like a small girl and she is not being able to breathe, but you consider that she could be staying for longer, and then you miss, then you are like attempting like going against the right to live. And all these considerations should be like taken into account. And we see that we have these ideas, these deeper representations of what our motivations are, that are values. And here are some examples of it. So getting closer to what a value is, we can think about its structure. So in the traditional alignment, they consider that your values could be captured by some sort of utility function that describe your preferences towards different states of the world. But then we have this notion of value system that is like, oh, no, you don't have just one criterion. You have like several criteria that are these values that are made to create actions, like to decide over actions, and that they can be like contradictory against each other. And then this notion of value systems, that is the one that we're going to use, is that you have different set of values, but also they generally have like a preference structure along them. So what represents your actions is like your most favored or preferred values, but like a lot of them are like in interplay. And with this, we have seen like the structures of values, like in a value system, but we shall not forget that a value is just like a human criterion to distinguish what's good and what's wrong, what's good and what's bad. And we could formally like give it a function. So a value has like an associated function that decides a score toward different actions or world states. And imagine that we have like these two values of security and the other value of freedom of movement. So if you had to decide like which of these actions would they like agree, or which of these policies would they be like aligned with, maybe you obviously say that, yeah, the freedom of movement has to do with freedom, and like the checking like your ID in a security control is related to security. So there is this alignment between values, or like this relation between values and actions or states of the world. And then if you prefer freedom, maybe you think that you should not show the ID because you should be able to move freely. But if you consider that security is a more important value, then you would prioritize the other. And all of this, there is like a line of research trying to face like AI alignment that is focusing on, okay, exactly what are these values? What are the values that an AI should align with? And in order to get there, what they try to do is like, okay, let's first identify the most important values, then let's estimate them for each individual, like what are their preferences, and then let's aggregate this structure of value systems. So these are the 3 steps, because we're going to focus on the last one. In the beginning, you get like the context, and you pick the value names. Then in the next one, you create the priorities for those different values. And at the end, you get like all these value systems try to be aggregated. That is what we're going to focus. And while the other 2 problems have already been studied, and they still are being studied, we see that this last one, and this is a framework that exists since 2021, it has been like understudied with just this one paper from Lera Larry that was showing like a possible way in which you could aggregate what a value means and also aggregate your preferences over your values. But that led to inconsistencies, so we decided to talk about these guidelines. And then there is this second thing that is important, because the problem of value system aggregation and the aggregation of our values can pop up as very useful in some democratic, obviously, exercises. And we're going to focus on one, which is participatory budgets. Because we live in democracies, but we are just able to vote every 4 years. And there have been like attempts from different parts of the world in order to make democracies more participatory. And one of them is trying to do participatory budgets. So this is the example of Barcelona that had like a huge launch at the beginning of the 2019, in which they are proposing in a similar way to other countries these steps in order to citizens to propose ideas, then debate these ideas, and then decide which of these projects or proposals that were initially decided can be prioritized, and how should the money of the municipality should be allocated, which is the main thing. So how much money do you invest in deciding participatory by the citizens? So this idea is important, because at the end you get like, imagine you have like a threshold of how much money you can give. You get like 7 proposals that have appeared after a participatory scheme. And just to show that this is like useful and this is happening, and that there has been an evolution of all participatory budgets around the world for the last decade. And the important thing, and how it is related to value system aggregation, is that one of the problems it has is that one of the problems participatory budgeting has is that you don't see all the population participating, because obviously perhaps they don't have the incentives or they are not that interested. But the point is that at maximum you get 5%, which is quite a lot, for example, for cities like Barcelona or Paris or New York. And how value system aggregation or this idea can get closer to it is because sometimes most of the people participating are biased toward like middle or high income families and like close to liberal ideals. So even though this is open to everyone and one could accept that is still fair, the idea is try to leverage all the opinion or the general values of different parts of society and try to give like a consensus value system that can also help to guide this decision making. And the last thing I would like to mention is this idea of social choice, which is this branch of mathematics, economics, and political systems, in which we try to make decisions out of like a lot of individuals. And it is a branch that has largely studied the problem of aggregation and how to bring different inputs like votes into a final decision. So we take some of the formulas and some of the methods from social choice, but still their main focus is on like some specific structures like preference order. So not necessarily like preference aggregation is not necessarily value system aggregation, and value system aggregation, the idea is that you are trying to give this extra structure to the idea of value. So you are not just preferring objects, you are preferring your values, and your values influence the objects, which gives this layer of interpretability. So then let's start with the guidelines for value system aggregation. So the first one and it's a key one, is how do you understand values? So let's take the example of security as a value. People can understand that security means having guns and having the permission to have guns, because that way you're gonna create like a more secure society. Some people may disagree and may say that no, having any sort of gun is not secure, and you're giving like freedom for like to other people. But these two interpretations of security exist, and we can think, oh, which one should we take for aggregation? Because we, at the end of the day, we want to have like an output. So you can allow different interpretations and then try to aggregate those interpretations, or you could just try to like force one specific interpretation on everyone and be like, oh, if you prefer security, this is what security means for the purpose of this situation. So this is the first consideration to have. So it has its pros and its cons. If you ensure that everyone has the same interpretation, you would be in a universal judgment in which every judgment is the same. And this has some pros, because you may have like the preferences are directly comparable between each other. And it is also easy to estimate. When you try to estimate like one's value systems, you are like, oh, we already know what your interpretation of the values are. So we just have to order your preferences over the values. But you are putting like more effort in the part of identification of values, because you don't have just to identify a label or, oh, this value seems important. It's like, no, you have to give a proper definition for the value. So that is a bit of a challenge. Then it may not capture all perspectives, because my interpretation of security maybe is not the one used for the example. So I'm feeling not that represented with the process. And also like the outcome is very clear, because what people think about security will be a clear thing, because we know what security is. And on the other hand, if we see individual judgments, you allow like more individual interpretation and like more diversity of perspectives. However, the preferences of the values are not clear, because the amount of preference that you give to a value may not be meaningful for other person. And there is also a problem with the output that we have the same as before, because what is the meaning of this value? Is it still open? And also it's an extra effort, because when you have to estimate one's value system, you also have to get their interpretation. So it's an extra structure that you have to take into account. And to this conversation, we can think, okay, how shall we solve the shortcomings of these two views? So one way could be try to do like a clustering of similar interpretations. So you're just willing to aggregate views on security that are similar to each other. You cannot aggregate two different things. And that way you would like try to do clustering, and value system aggregation would be like an exercise of finding the most important clusters that represent different sections of society. On the other hand, you can think about doing more an exhaustive value identification, in which you don't find a value as security, but you find a value of public security or like private security. And those have like different meanings, and maybe that is more meaningful to do an ordering or a ranking. So let's go with the ethical principles of aggregation. So this is an idea basically of how do we treat minorities throughout aggregation. And for this, we try to like get closer to some mathematical model or simple formula in order to get like a parameter to know whether that would be closer to like fully including minorities and giving them like the same voice as the majority, or rather giving the majority like a proportional voice. So the point is that if we think about aggregation as like distance minimization, that means that if you get like a bundle of points, you try to get the one that is the less far away from the rest of the points, but that using distance and trying to like getting this optimization problem. There has been some work that if you do LP regression, LP being a metric on a vector space, whose formula is here. But the point is just like a distance function. Then you can get this sensation, because you get the P norm, and the P parameter is gonna allow you to have like different interpretations. So imagine we get like these 3 points, 5, 6, and 10. And if you were going to aggregate them, one way of doing it is the mean. And you can get the mean of that. And the mean would be 7. And that would be equivalent to p equals to 2. Because p is going to be a parameter that goes from 1 to infinity. And p equals to 1, which would give you the median. So in this case, 6. It's like the utilitarian solution. Because what that is doing is minimizing the absolute distance to all the points. So if one minority gets like very far away, but the rest of the people is close by, moving the point closer to the minority is gonna like reduce the utility. So you get like, this is a mathematical concept yet. So p equals to 1 can be associated to utilitarianism, while p equals to infinity could be associated to this principle of fairness, of trying to reduce the maximum harm for the most the person that is worse off in a like population. So you try to reduce their harm. So that is like fully focused on minorities. So we can say, okay, let's take the utilitarian approach. If one were to decide an aggregation method with this principle in mind, there will be perhaps a risk of bias of ignoring the minorities. But if we have like low dispersion input and most of the people is close by, it will be very representative because you're going to be maximizing this idea of utility. But if it's not, if there are like a lot of minorities, they will be like not represented. And we say it's readily applicable because once you set this parameter p equals to 1, you could use this mathematical function directly. A similar thing happens when we take the Ralston approach. It is readily applicable because p equals infinity. That results in like mathematically just using like the maximum distance and forgetting about the rest of the formula. And it will be the best if you have like a lot of minorities, like high dispersion input, and will give you the best solution, which is the fairest to the outliers, which is the concept that we mentioned before. However, if there is like not a lot of dispersion, it will be just good because it will probably give you like a very approximate solution and quite close to p equals 1. And again, it ignores the majority, so there is that risk of bias. So you can take an intermediate approach by taking p equals to some number between 1 and infinity. So if you chose it properly, there should be no risk of bias. Sorry, that should be green color. And then we got similar results, like an intermediate result in the other two, but it is still hard and an open question, which is the appropriate p to use. And with this, we're going to move to the third guideline, which is about whether you should create like a method, an aggregation method that is general or one that is tailored for a situation. This is more like a question about how to use our resources, and that sometimes it is good just to copy a method that has been given to us, or on other cases, it is better to create like a brand new. So imagine you want to, like you're a small municipality with limited resources, maybe you want just to take one directly, but if you have like a very focused effort and you're a bigger municipality, then maybe you want something more specific. And we put the example of the minimal decision divergence, that is a property that we have thought about, that if you want the decisions of this aggregated value system to be very similar to the decisions that would be produced by the individual people, then if you want to minimize that distance, is not the same as trying to make the value systems similar per se. So it would be like a specific property that you would think of. So here are, again, the pros and cons of a general approach. So that we have one method available, as I've said, that was by Larry, and that it requires little economic resources because it's given, but also it has the problem that it may not be good enough for the exact thing that you're looking for. And then in the tailored approaches, we still have no methods, and there is some investment needed, like you will have to do some research. And then the optimality would be ensured. And the final bit of this talk, the last guideline, is about considering the suitability of aggregation itself. So we've said that in aggregation, there is no talking per se by the subjects, by the citizens. They just add up their value systems. However, we can think about deliberation, which is right the opposite, right? It's just no math, there is no formulas, and you just add up and work by voluntary compromises. So obviously there is no pure method between either of them. Even like voting system, like an election, there is like weeks of discussion before, and then you do the aggregation, which would be voting. But even in like very assemblyary like methods, like the Occupy Wall Street movement, they start being like, no, everything is going to be assemblyary. But at some point they accept, okay, let's put like a 90% threshold for all our decisions. So they're doing some sort of aggregation of like majority voting. And they both have their pros and cons. And this is also like to open the space and the conversation to focus on these hybrid approaches and to put them in consideration. So for aggregation, you would have imposition of the results. So if this is intended to be a representative system, you have to accept that you don't like your president because it's a fair solution because people have voted. And on the other hand, you have like, it can satisfy formal properties mathematically. You will have always the same output if you have the same inputs because it's a formula, because it's a function. It's usually not time consuming, although if you have like very computationally untractable problems, it may be. And also the necessary input, like a value system is not something that you get by default. You have to do like huge investment in it. On the other hand, deliberation, it is like there is no input required beforehand. And this is very important because people just can come voluntarily and talk. But you may need to recruit them into a specific place. And then it can be time consuming and it can also affect the results, just like group dynamics, like polarization or groupthink, which may not be optimal, but obviously encourages voluntary compromises. And with this, I'm going to give this last slide about the future work. So value systems and the value alignment field is quite open. There are like questions to talk about. For example, how do contexts influence like the interpretation of values, or which are the best methods to estimate the value system of people, or even think about these structures of values that I have presented just as like a preference and each value has a function. These are things that are still like being thinking about. So I'd say that for the value system aggregation, thinking about a more tailored methods, for example, with the minimal decision divergence property, or think about how aggregation could be done, and think about the new methods, which has been already a bit saturated in the social choice literature, but could still be like applied in different ways here. And well, there are like open topics that we can keep talking about. And that was the presentation. This is the research center at my university, CIT-AI, which is in London, in City St. George's. And this is Marc's, which is not here, but I think Marc Serramia, he joined the presentation. It is his research center that we are also like a good relation. And here you have the rest of the QR codes. Thank you very much.
Any question? Yeah, I have a question. In the deliberative approach, it seems that in the recent days, recent years, lots of these discussions are poisoned with lies, people presenting lies as truth. And so the whole deliberation is completely meaningless at that point. How do you fight against that?
That's an interesting question and an important thing to think about. So I bring deliberation here like as an important question if you're gonna design like an aggregation method and something to have in mind, that deliberation is also like a part and has been the solution for human conflicts throughout history and in our personal relationships. So what you're mentioning, it's something that when you're creating like a process that involves deliberation should be taken into account. And usually in controlled spaces where people are like more prone, like they have some ideas in mind and that they know that they will have to compromise at some point. What you also have is like some moderator that has like some extra facts and can like contrast what it's been said. But at the end of the day, the deliberation risks to some extent the problem of manipulation. But yeah.
Okay, question. So the aspect that you provided for protecting the minorities, so just correct me if I'm wrong, so it corresponds to finding a trade-off or balance between the majority power and the minority protection. That's basically what you are looking for, and considering, of course, noise and bias as the question that has been asked before.
Yeah, so the main idea is that if we represent society and we see that we can do potentially some clustering of what are the main opinions of people, we will see like there are some groups of people which hold like some beliefs that are quite distant to perhaps others. And the idea is, if we wanted to like get maximum utility and we create like utility parameter, maybe we're gonna get that the solution is still in the majority and in the mainstream, we can say. And if that is something that we don't like as a society that values diversity, we can try to think about other ways and whether the solution should incorporate parts of the minority or be like less positioned in a way. So the idea is to use this parameter which gets closer to the majority or gets more outside, basically.
In preferences, I mean, there are several methods that actually do that.
Yeah.
I mean, you are dealing with your preferences initially are ordinal preferences, right? Ranking. So aggregating ordinal preferences and considering minority, there are 4 or 5 main methods that I think should be considered as well, just to check.
Yes. This was more to bring the conversation about the ethical principles for aggregation, and we give the example of using distance-based minimization as like an aggregation perspective, but it's not the only one. So this is just to give like the general guideline to when an aggregation method is provided, but it's not intended to be the only one, and there are more of them.
Okay, since speaker again, thank you very much.
I'm happy to take more questions later or in any other time.
Yes. Cool. Yeah. So she's already there. Ah, okay.
I just need to put my computer over here. Use the share.
Maybe like this.
It's good. Okay. Yeah.
Dr. Marc.
No, yes. Question. I need to share my Zoom. This one. Okay. Yeah.
Let's see. Sorry. The second speaker is Dr. Bonnet-Paul.
Yeah.
Okay.
Yeah. Hello, everyone. Jawad Haqbeen from IBM Research, and this work was done with the collaboration with Sara Migliorini. She's a lawyer and professor on law at the University of Macau. Is it better like that? Okay. Yeah. Yeah. So basically, the question that we raised in this work is mainly LLM is in court, and what's the risk and the governance of LLMs in this judicial decision making. So what can we say? So basically, LLM are already here, like GPT, Claude, Gemini, and others. And people are using them for what? Drafting, summarization, writing, and also case law analysis and study. So the judge at the end, they are highly using those tools to make decision. And then the question that rise out of this, let's say, system is what happened with this usage. So for instance, people could use different LLM, and those different LLM gonna have like different decision and different like there could be a disagreement. Like it's gonna be depends on prompting and biases, and like all this could lead to some loophole. So the core question that we were raising was mainly, do different LLM produce different legal interpretation from the same source of text? Can this divergence create, let's say, an exploitable legal loophole? And what governance and framework can we can mitigate this kind of risk? So the methodology that we come up with is the following. So we have used 4 LLMs, so GPT-4, Claude, Gemini, and Llama. And like we identify 2 data sets, two legal data set, where those data sets are in a setting where it's, let's say, a question and answering. So the 2 of them are Casehold and Lex Glue benchmark, so available on internet. And we basically do a semantic analysis and loophole detection on each of those answer of those LLMs. So basically what we have done is we took 50 legal prompts. We prompt those LLMs, those 4 models, and we do multiple prompt variation, which means that we have the same question, but we make it different, we modify it, but to maintain the same semantic, let's say. But what we were wondering is what happened with that. So basically what we were targeting is 3 loopholes that we, like through our study, we defined them. So the first one is the missing critical legal provision, where basically the LLM failed to cite relevant status. So it's going to say something, but the reference that points to it is wrong. I mean, similar to when we ask for, let's say, writing a paper and it's gonna like give some wrong reference. So it's affect also the legal let's say community. And the second one is mainly elucidation, where there is no existing court decision that he come up with, or fabricated legal code that is come up with that never exists. And basically, the third one is prompt sensitivity. Well, what the question that we raise is, what happens if different conclusion come from the same fact, basically? And this is like definitely susceptible to manipulation and, let's say, adversarial prompting, which means that you can prompt the LLM in order to get what you want as an answer, basically. So, key finding. So what we have done, like as I was describing, is as an input, we have those prompts, and we compute cross-modal semantic similarity. What this metric means? We basically took the output of each of those LLM. We put them through an embedding, BERT embedding, and then compute the similarity between each of them. So it's kind of, you end up having a matrix where you compute the similarity between GPT and Claude, Llama, Gemini, and so on and so forth. And out of that, basically what we observe, I mean, of course, you guys are gonna tell me their LLM is like changing every day, so those results doesn't mean anything between like what we have when we submit the paper and now. But at least it gives us some sampling of an overview of what exists. So and let's say the core information that we get, it's not about like which one is close to what, but precisely the disagreement rate. And disagreement rate is around 20%. And then the question that comes to our mind is, are we going to allow this percentage of disagreement in such let's say domain or environment? So that was the target of like for us running this type of experiment. And what we can see is there is a high percentage of disagreement between LLMs. So like the target is to say to the community of judges and lawyers, be careful on using those tools, in a sense that this 20%, it's gonna definitely highly impact like the results of how you're gonna make decision out of some specific let's say court decision. Another evaluation that we have done is basically the prompt sensitivity. And prompt sensitivity is mainly, let's say you took a bunch of prompting that have like the same meaning, but what we do is we do the embedding out of the results and compare those embedding. And the semantic drift means how far let's say the LLM the answer of the LLM are between each other for this, let's say, the same semantic question. And what we observe, I mean, it's pretty high, like spamming between 18% to 27% with high variance. So and then so basically what we can say is there is like a legal interpretation that change whenever we change the prompting. So basically the key finding is we observe that there is like high injection rate. Some of them struggle with framing sensitivity, and let's say the key finding would be no model is immune to all those loophole types. So we cannot say that, hey, this LLM is better than the other, because one has an issue with prompting, the other one has an issue with hallucination, the other one doesn't give a right reference. So like, why this matter? It matter because it bring like a system risk, in a sense that that could like increase the inconsistent legal process and reduce the public trust on those tools, like a high bias. And I think the main important part is the erosion of independent reasoning, in a sense that if lawyers start or judges start to rely on those LLM to make decision, and then you remove them, like same as what like professor from Tokyo was from Japan was presenting about student using LLM and not using LLM. Here it's same, like if the judge they start using LLM and then you remove that, or maybe those LLM are corrupted with those different issues that are rising here, that's gonna be create a big issue. So what can we say? So on one side, you have human with the bunch of the errors, let's say, and mistakes that he did, the biases. Human are influenced by, let's say, time of the day, influenced by external stability and framing biases. So we do have this like what I was criticizing in AI. As a human, we also have those kind of issues. And the main problem is when we goes to like trying to introduce AI, the hope is try to reduce those effects, but in reality, what we observe it's kind of increase them. And then the main question is we need to carefully integrate this tool in order like to go to the right direction, basically. So what we are proposing as a possible governance framework is basically, for instance, the use of an ensemble model of LLM, in a sense that what we observe is that there is like every LLM has like some issues. So maybe one way is, let's say, use multiple and maybe having a tool that highlights the disagreement between them and help, let's say, the judge monitor those different points of view. And this could also, let's say, bring some bring and require some transparency where we know that the judge was mainly like using the LLM, how it is using them. Sorry. And also like a well described process of audit where we want also the judge to be like trained and understand the systems that they're using. Otherwise, they took whatever they have as a fact. Maybe what happened is people used to use computers as database, and then they don't know the switch. They don't know what does it mean to be a generative AI. So they thought that, hey, it's maybe like a kind of request and get feedback, and it's totally different. And it requires like a best practice and training and certification around those tools. So what we are proposing also as a mitigation strategy is, for instance, standardization, where in, let's say, those sensitive domain, maybe they should have some template or some processed prompts that are done precisely for this domain. And understand, trying to propose, let's say, an LLM with uncertainty quantification. Let's say if you have an LLM that tells you an answer and tell you how uncertain it is in this answer, it at least help you understand if you're gonna trust it or not. And of course, including human in a loop verification by expert. So the goal is to have technology to enhance and not replace human judgment at the end. So as a future research direction, we are thinking about, let's say, trying to run some empirical study on judge behavior analysis to see like what's the impact of those LLM on judge, see what's the outcome and impacts, and also run some cross-jurisdiction comparison to see the impact of LLM for use and not use. And also, like from technical development, it would be interesting to have some robust benchmark where LLM could be used on those benchmark and see how good they are. For now, like the only dataset that I have seen are like only 2 of them, and they don't spam over all the problematics that we are facing with including LLMs on judicial practitioner, let's say. So the call for action is basically, we can say that LLM are already being used by legal context. And like we cannot say, hey, just wait, don't use it. We need to figure out what's going on, and then it's too late. As long as GPT was put on the website and the rest, like everyone is using them. And don't expect to say, hey, we cannot. So in order to do that, we need to come up with a governance framework and create the right technical standard for legal AI, instead of letting it right now as like an AI in a wild, where everyone using it thinking it's the right tool for it, and every day we discover that there is an issue. Like people are using it for psychology and discover that it creates issues, and medical and create issues, and now judicial and create issues. So we require to move fast and try to come up with the right tool for the right domain. Yeah, so let's work together to ensure AI enhance justice rather than undermine it. Thank you.
Any question? If I can ask 2 questions?
Sure.
The first, in your comparison,
Mm-hmm.
I'm just wondering how you address with inherent bias that there's an absolute answer to a legal question. Because if I take a look as an example, 50 years ago, Roe v. Wade defined abortion in the US, which was overturned several years ago, which was, it was almost a 60-40 split, so majority. But how do you deal with the fact in your comparison that there is a subjectivity to the interpretation and the framing of those questions to get an answer?
Good question. So, like we noticed that, we know that there is a subjectivity, but the good thing is we rely on the data set that already exists, where those specific questions that they have in the benchmark are the one that has the less subjectivity, let's say. But of course, let's say there is like in this construction of data set, those people it could have been criticized because you can like create a wider span where there is like more uncertain decision, and for now the data set that I point you to that are like question where there is like the uncertainty is low basically.
So a follow-on question.
Yeah.
When you did your LLM comparison,
yeah,
based on specific set of facts,
mm-hmm.
Would you in the future use some type, or maybe it was implicit in the way you did it, a control group? Because those facts were interpreted by legal scholars or something, I presume, and there was a rendered answer. So it would be interesting to see how the LLMs compared to the legal scholars and what the variability amongst the legal scholars would have been, whether it was also for 20%.
Definitely, that was the first goal of our study, and then Professor Sarah is in Macau, and she had an issue with Chinese authority in order to have the student working on this project. And I said, hey, no worry, we will work just mainly on LLMs, and we try to avoid this this legal process over that. But the first motivation was run LLMs, work student on like she started doing it, and then she had like a hold from her department. But the issue is like we are a company and like from the US, and they're like related to China. It could have been like different if we had like different yeah.
Thank you for your presentation.
No problem.
My name is Sean. I'm a researcher at RAND, so I do a lot of policy research. So this is quite relevant. I'm curious. I saw the models that you were using. I'm wondering. I'm curious. Why did you not use like chain of thought reasoning models or like GPT research or anthropic research and things like that to fine tune instead of using less earlier versions of the models? Was it like compute constraint costs, or was it easier to fine tune these sort of models versus like using like the higher end models?
No, good question. Like the first thought that we had was like what is like the usual use of common people on those LLM? Is that gonna be like those like highly specific LLM with chain of thought and whatever maybe fine-tuned, or it's just mainly just going to ChatGPT and write whatever you have in mind and get an answer? So for like I definitely agree with you that it could have been and maybe like it would be maybe next step is to wider the span of the research, including chain of thought. There is a possibility also to play with the size of LLM to see like if there is impact on like the number of parameters. But I think the core idea of this paper is just to bring like to have a glimpse over what happened with different LLMs used in this domain. But yeah, I definitely agree that as a next step we can like push toward. Yeah.
Yes, that's what the judges are using. You were modeling. Are the judges using the ILM models?
Yeah, that's a great question. I can say that, for example, at RAND or at White House and some government agencies, they're only using GPT-4 right now. I don't know about like the district courts and things like that, but they have to train poster models like on-prem, and a lot of them place them behind because they don't have like the engineering capacity to do this.
Yeah, that's the intuition that we had. So like, yeah.
Thank you for explaining.
No problem.
Any other question?
Yeah,
Oh.
thank you very much. I have to ask your comment, Idiot. How about if you use, like, let's say, use LLM as a judge, and then take the decision making at a data set, and then apply human in the loop AI, then develop another agent AI to judge that quality, like many agents try to apply to evaluate the quality of decision making of the previous deployed agent, and then on the outside, inside of those, make a like combined human AI proper judgment system. Do you think that such approach might be as an emerging future model or system in the decision making or not? What would be the future?
So I get the first part where you're saying that you take an LLM and you evaluate another LLM.
We evaluate the content of decision making.
Yeah, so that also create another issue, which is basically when we were running those experiments on LLM as a judge, we observed that LLMs loves themselves. So if you show GPT an answer that comes from GPT, it's gonna like it. And if you give to Llama an answer comes from Llama, it's gonna like it. So basically, there is like this big bias. So if you think that it comes from whatever it's generated, it's gonna give like a thumbs up. Otherwise, so that we are scaring over biases. But we're definitely hoping to have, let's say, an ensemble of AI that gives, let's say, an answer, like a diverse answer with a diverse perspective or point of view. And I think this part would help the judges being more open-minded of what the possible answer is, and not just even like just by human. We are already biased to what we learn from the past and what we observe over the past. So yeah.
Okay, thank you very much.
Thank you, guys.
Oh. And
yeah.
Could you please go to your email address? I send you the Zoom link. You just share. This one? Yeah, this one. This one.
Okay. So third speaker is me. So I'm Takayuki Ito from Kyoto University. I'm happy to present this this result. The effect of AI participant on online group deliberation. So for this paper, I focus on the Afghan youth basically. So there is a wide studies about AI mediated discussion supports. So actually, there are these days, recently, the AI-driven mediators are very known as a effective way to summarize the people discussion and also promoting the deliberation, and also it could be the unbiased and inclusive discussion promoters. So there are several example systems like DAgree. That is one of the system we created. There, AI facilitator, AI agent can facilitate large-scale consensus support system. So yeah, actually we developed the AI startup based on this system, and yeah, we deployed this system in the world and also in Japan in multiple local governments. And also in 2024, the DeepMind proposed the Habermas machine. That is also AI-mediated deliberation support system. Here, yeah, their claim is that AI can help the humans to find a common ground in democratic deliberation. So yeah, these kind of studies about AI-mediated discussion support is now very hot, actually. So here, in this study, we focus on the AI participants, not facilitators. Okay. So here we are we are studying about the effect of the AI participants. So here, social presence theory suggests AI agents capable of responsive and human-like interactions can be perceived as adequate peers in conversations. So this actually aligns with the paradigm called computers as social actors. So by providing the AI participants in the deliberation and discussion, so we can expect a positive effect, actually. Yeah, to do so, by doing so, AI participants may improve collective intelligence and shape group dynamics positively. Okay, but of course there is some risks like humans overly rely on the AI opinions, and also AI's opinions are coming massively, and human cannot say something, cannot participate in reality. So in this study, we use one agent in order to distinguish such a participant agent is effective or not. So, and also we did experiment in the Afghan context. So Afghan context is urgent and significant to using AI in deliberation. Because of the conflict and also traditional civic dialogue, yeah, actually, in Afghanistan, it's these things are traditional civic dialogues remain dangerous and impractical, actually. So also, recent regime changes restrict civil liberties and increasing the needs for safe online spaces. So, but Afghan youth remain civically engaged, making AI enhanced online deliberations a critical alternative for inclusive civic. So this is the architecture of the hyper-democratic system we developed. This is actually the second version of the D-Agree, actually. We improved that we can we improved the D-Agree system so that we can manage multiple agents in the discussion with the people. So we can use the D-Agree system and also other web forum system as a user interface. And these functions are all deployed in Amazon Web Service. And also, these agents are all can be connected to the LLMs, including the OpenAIs and also open source LLMs. So we did several experiments by using multiple agents already by using this system. And as you can see, we published some papers, for example, ACM collective intelligence. But here, in this study, we employed only one agent so that we can see the effect of the agent itself. So this is an example of user interface. Yeah, this is actually based on the web forum called Discourse. And yeah, we can use other web forums as a user interface. But here for this study, we use Discourse interface. Okay, this is an explanation of the method. We have, yeah, this slide explains the participants and design and the research experimental design. We gathered 80 Afghan youth, ages 18 and 39, and then genders are balanced, and also undergrad level education is mandatory, and we check the proficiency in English, and also recruitment was conducted using the stratified sampling approach to ensure demographic and the diversity across gender and education background. Yeah, this is I mentioned already this. So this is how we make groups. So participants are randomly assigned to 20 discussion groups consisting of 4 members. And these groups were then divided in 2 experimental conditional batches. The batch 1 is a control group, no AI. And batch 2 is an experimental group with AI. Okay. Actually, the AI has a name. It's Anna. The avatar is like that. So it's a familiar avatar, actually. So this is the procedure of the experiments. We have 3 days discussions. In day 1, there was a pre-discussion survey, and that followed by an online discussion. It's I think 5 hours online discussion. And then in day 2, discussion continues with focus on defining ideas, exploring the deeper viewpoints. And then in day 3, final discussion was held. Here, the participants focus on the wrap-up conversation and did discussion survey. Okay. Yeah, we set up several measures to measure the discussion quantitatively and qualitatively. Okay. Yeah. So, for example, as a quantitative measures, we as a quantitative measures, perceived usefulness of discussion format and context, and the ease of interactions, and the expected actual levels of participation, and degree of opinion change over the course of discussion. And also, as a qualitative measures, the surveys included the open-ended questions. And also, we see the keywords that are submitted by participants in the discussion. So I'll explain one by one about these measures, about the result of the experiments. So the first one is a perceived usefulness of discussion itself. Okay. So yeah, there are 2 groups, no AI and with AI. So here, the result say that the AI groups ratings for the usefulness of discussion rose from 73% pre-discussion to 85% post-discussion. Actually, this is surpassed the control group's slight increase from 78% to the 81%. Okay. So yeah, importantly, the 83% of participants in the AI group explicitly rated the AI participants as effective, and suggesting that the AI added substantial value to the diet, actually. So this is the result of participation and engagement. So actually, here there's no big difference between no AI and with AI. But for each group, for both group, because of this is our expectation, but by so actually the participants in both groups can participate and engage very much, but because of the agent presence, that can maintain the robust participation by human, I think. So next result about the ease of interaction. So this is this has a significant result actually statistically. Participants in AI group reported significantly improved ease of interaction actually. So by providing AI agents, that people can interact easily compared with no AI situation. That I think that can be understandable because AI can post more messages compared with the human itself. Therefore, the interaction can be increased actually. So this is ease of interaction. Actually, this table and this graph show same thing, but here with AI, interaction improved. So this is a result of degree of opinion change. So actually, both conditions experience opinion shift during discussion. Here, slightly higher rates in AI condition. If there is an AI agent, the opinion change slightly higher, but there is no statistically significant result here. But in another experiment we did, AI can tend to change humans' opinion more than without AI condition, I think, in our other experiments. Therefore, yeah, we need to deepen and pursue this direction about the degree of opinion change. And also keyword analysis, thematic analysis. Yeah, there is some difference between the no AI and the with AI situation. Okay, in the situation without AI, no AI, the words has not been changed so much. As you can see, in the top line, no AI. In initial phase, the people has a keyword like Taliban and education online, but these keywords are not changed even in the post-discussion keywords. But with AI, it's a bottom line. The keywords are changed from the initial situation to the post situation. It's also good because the keywords tend to be positive compared with the pre-discussion keywords. Okay, so from this we can think we can expect that the AI presence can help people to be more positive in the deliberation. I think because the Anna is the AI agent here, Anna is actually characterized as a very kind female character. Therefore, people can be more positive in this deliberation. Okay. Yeah, this is a summary of statistical analysis. So as you can see, we we could get the significant improvement statistically about the ease of interaction. So interaction improved by using one agent. Okay, I think that this is reasonable, but we could not find statistical significance about perceived usefulness and opinion change in this study. So this is a discussion. Actually, as I explained, the one agent can enhance the interaction among people because the agent can provide more opinions. I mean, the posts compared with humans. Therefore, people can tend to be more positive to say something in the deliberation. So that could be connected to the positive effect of the keyword itself, I think. But yeah, we need to investigate more about that point. Yeah, in the future we are going to do that more. So yeah, that's actually I provided the implications. Yeah, for the civic technology, AI can foster inclusion and idea generation in marginalized settings and other educational platforms. AI discussants may stimulate creativity and broaden discourse in online learning positively, actually. As a system design, optimal use is as a peer, not a replacement of facilitation. User transparency and ethical safeguards are essential. Actually, I didn't mention about that these things in this study, in this presentation, but in the implementation of the AI agent, we have some safeguard by using a template so that the agent cannot say very bad word or very bad things. So agent basically follow the template first and then improve that template to say something. So that is one technique about safeguard. But yeah, it's not enough. There's a limitation. Yeah, but that kind of things is required to investigate more. So conclusions. We developed the hyper-democracy system. Here in this study, we focus on only one agent. How such one agent can effective to the discussion among several people, multiple people. So here, insight, the findings is actually the interaction, ease of interaction is improved, even if there's only one agent there. But we cannot find statistical significance about opinion change and other things like usefulness. We need to investigate more about that. And also, in the further research, should explore AI agents' role more. So here, as I explained, Anna was characterized as a very kind lady participant. But yeah, of course, here, yeah, actually, we can imagine the other kind of the participant, like very critical participant, and also very pessimist participants. And actually, in other studies, we did such experiment with such different character agents. And we got several different results for each agent. But here, yeah, we need more about, how can I say, because here in hyper-democracy system, we can implement several multiple agents. In other studies, we mix these agents in the deliberation. But to see the statistical significance for each measurement criteria, we need to see only one agent that has different roles, different characteristics. So that's all. Thank you very much. Any question?
First, very convincing and impressive result that it changed the tenor of the conversation. Have you considered doing a follow-up to see if the participants have learned how to interact more smoothly after the agent is gone, like the withdrawal effect we were speaking before? Or is that something you're considering as future research?
Yeah. So we need to think about that, and also, actually, we got a questionnaire about that, and we need to analyze the result. But here, this is the initial presentation. Therefore, I don't have that.
I have a quick second question. What about the opinion changes? Was there a directionality to those?
So I think yeah, there's a direction that as we understand the keyword change, so that the direction of change is more positive actually in this study, but it depends on very much about the context, I think. So we need to think about the context more about that. So we cannot say every time agents can make people positive, but in this case, yeah.
Thank you.
Okay.
I just want to make sure I understand, when you refer to the AI agent's role, you understand you're referring to the gender of the voice, the personality of the voice?
I see. Yeah. Thank you very much. So yeah, here I wrote AI agent role, but yeah, in this sense, we can implement the agents like facilitation agent and also translation agent and also the summarizing agent and also how can I say basically skills based on skills and the roles, and also we can differentiate the agent as characters. So I mentioned both in that presentation.
Yeah, just wondering from you, what I think was your earlier research, where you looked at the personality of the voice or the gender of the voice, because this group I think was like 18 to 39, having someone who would be perceived as a peer and to facilitate discussion as opposed to a more senior person who might be more restrictive. And how you think that would affect or could enhance.
I see. We have not done such analysis, but yeah, it's very good direction. We need to think about that more.
Yeah, so I was looking at your result of the p-values. So like you said, like some of them were not statistically different. I'm not here to advocate for p-hacking or anything like that, but I was out of curiosity, like, where do you think are the greatest places to improve this research in terms of showing the impacts of AI? Is it, increasing the sample size? You guys did 80, would you want to scale that up, like, 5, 10x? Or would you want to do some sort of fine tuning on Anna to potentially maybe what do you think the lower hanging fruit or the more significant improvements can be made?
Yeah, so actually our group is doing different, how can I say, multiple different directions. So one is LLM improvement itself with fine tuning and the lag system, lag way, and also we implemented the AI agent using LLM, like the how that agent should interact with the discussion itself during the deliberation process itself. So AI agent can, by using LLM, AI agents can judge how they behave in the deliberation in the first phase and the middle phase and the last phase, for example. So yeah, these things are all investigating now in different groups and different directions. So yeah, we need to show the results step by step for each direction. Thank you very much. Yeah.
What is it you tell the AI to receive some specific instruction on as to how it's supposed to interact with?
Yeah. Thank you very much. In this study, Anna is AI agent. So here, the AI agents basically interact with the humans by using web horror, and AI agents can in some step, AI agents judge how C behave at that time by using LLM. So for decision making, we use LLM, and also how C make sentences is also done by LLM. So, but yeah, we can provide the source code of Anna itself, but it depends on the studies, how we implement the AI agents. One thing I want to say is not only LLM. We use the outside Python code, and the Python code can manage the LLM. Okay.
Thank you. I would like to ask how reproducible is the preparation for the AI agent so that it can be generalized to discussion in different settings, so that we can trust this fact that it is an helper to discussion in a more general sense.
Yeah, so that's actually very good question, but a tough question for me. So yeah, so in some application, the agent should know the deeper domain specific knowledge more than human. But in some application, that, for example, only for the facilitation, then the facilitation agent should know facilitation knowledge only, for example. Yeah, that is a sometime domain specific very much, but it's really depending on context, I think. So yeah, sometimes we need time to implement agent itself very much, but sometimes we don't need. I think it's a general behavior. If the domain is enough for the general behavior, then we don't need to take time so much to implement the agent itself. I think so. Okay.
Humans aware that NR is not human. On human, even humans know that NR is not human.
How do the humans know that Anna is not human? Do they know it's an AI agent?
In this study, the human know AI agent. Yeah. In another case, we did the human does not know AI agent, but yeah, we will publish that afterwards, so in the future. Okay, thank you very much. Thank you. So the final presentation is
yes.
Okay.
Okay, good afternoon, everyone. My name is Nuwair Al-Rashidi, and I'm a Master's of Applied Science candidate at Carleton University. So I'm very excited to be sharing my paper with you, titled Deep Learning-Based Multimodal Human Activity Recognition in Smart Homes using SDHAR. So as smart homes become more integrated into our daily lives, it's important. The need for intelligent systems is growing, and so are concerns for privacy, surveillance, and user autonomy. So in this study, we explore how to recognize human activities inside the household without the need for cameras, microphones, or wearable devices. Instead, we leverage non-intrusive sensor data, and which include appliance-level electricity data, to train deep learning models that are both effective and privacy-preserving. This work was supervised by Professor Qixiao Lu, and it's developed in collaboration with Grace Hospital, GRT Health, and Kyoto University, who are exploring real-world applications in aging in place and healthcare monitoring. So why does this matter? We want our homes to be smart, to help us save energy, stay safe, and support aging in place. But many current AI systems achieve that by relying on intrusive sensors, as mentioned previously, like cameras, microphones, or wearables. And these methods often raise privacy concerns, and they can be expensive to maintain, and they may feel unacceptable to users in private spaces like bedrooms, bathrooms, or shared households. At the same time, appliance-level energy data, which is already passively collected in many homes, remains largely unused in human activity recognition research. And it's largely underused despite being a strong and strong signal of occupant behavior. And beyond privacy, many existing HAR approaches still struggle in multi-resident homes, and they lack the multimodal context, which is needed to robustly understand human behavior. So our core objective was to develop and compare two learning models for human activity recognition. The first being a bidirectional recurrent neural network, and the second is self-attention model. And we leveraged the SDHAR home dataset. And most importantly, we evaluate how smart plug electricity data contributes to human activity recognition in realistic, privacy-conscious home environments. Let's take a closer look at our dataset. It is called the Sensor Dataset for Human Activity Recognition at Home, or SDHAR Home Dataset for short. This data was collected over 62 days in a real smart home with 2 residents and their pet. It includes 18 different activity labels, such as cooking, watching TV, or sleeping. And they're all labeled manually. And what makes this data set unique is its aspect of non-intrusivity, where it uses ambient sensors like motion, vibration, temperature, and light. And it also uses a smart plug energy consumption data. The data also includes Bluetooth-based indoor positioning that is only used to help us identify which user is which for our study. And although this data set does include wearable device data, the actual data was not used for our model, just to maintain our non-intrusive aspect of the project. So This chart shows our non-intrusive monitoring system, where we have our electricity consumption, and we also have the non-intrusive sensor network with light, temperature, vibration, and presence sensors, as well as our Bluetooth positioning sensors. And they're all found within the household environment. And eventually they would give us the 18 different activity labels that is needed for our conclusion. And to prepare the data for training, we applied several pre-processing steps. It includes temporal sampling, where the data is resampled into fixed 1-second intervals to create consistent time windows. We also have binary sensors encoded as 0 or 1, and smart plug readings. They were actually forward filled to capture appliance states. And we added cyclical time features like hour and minute, using sine and cosine to help the models learn the daily patterns. So we also oversampled rare activities, let's say like medication intake to handle class imbalance. And finally, we split the data into training, validation, and test sets using a 70-10-20 split while preserving the time order. As for our model architectures, first we have the bidirectional RNN, or bidirectional recurrent neural network. So this architecture was designed to model temporal patterns in the sensor data by processing the sequences both forward and backward in time, which is important in HAR because of past and future context that often helps disaggregate the current activity. So here we have our pipeline. Starting with our input layer, we have our pre-processed database. And the input is first passed through a dropout layer to reduce overfitting. And then the data is split into 2 branches, one that processes time features and another that processes the sequential sensor data. And so the sensor data is passed through the temporal encoding layer, and then it's followed by a bidirectional RNN. And again, we applied another dropout layer, then a batch normalization to stabilize and accelerate training. And at this stage, the BiRNN layer output is concatenated with the time feature stream, which combines the temporal and the contextual information. And this merged representation is then passed through a dense layer and followed by a dropout layer, and finally producing our human activity recognition output, basically telling us which activity is happening when. As for our second model, it's the self-attention model. And our pipeline starts similar to the previous one with our database. And here, in the first stage, we perform input reshaping. So we flatten the data and we remove time-related features to simplify temporal alignment. And then next, we apply convolutional layers to capture sensor-specific modality attention, which allows the model to learn how different sensors contribute differently to activity patterns. And next, we have the one-by-one convolution over time steps, which further condenses the temporal patterns before passing the data to the transformer encoder layer that we see here. So inside the encoder, we add positional encodings to preserve sequence information, and we also apply a dropout layer for regularization. And the data then flows into our stack of self-attention blocks, which enables the model to learn long-range dependencies and contextual interactions across all sensors. And a final global temporal attention is applied to help the model focus on the most informative time step, followed by a fully connected layer that basically outputs our activity label. So this architecture was designed to be both powerful and privacy preserving, which allows us to classify the complex and overlapping activities from ambient sensors without the cameras or microphones. And now that the both models are in place, we can explore our training setup and evaluation metrics. So to evaluate the models, we used 4 standard classification metrics, which are accuracy, precision, recall, F1 score, and each was reported as both a macro average, which treats all classes equally, and a weighted average, which accounts for imbalance by weighing based on activity frequency. And in terms of training configurations, here are the hyperparameters. So both models were trained using the Adam optimizer and a sparse categorical cross entropy. And for the bidirectional RNN, we used a smaller learning rate of 1 times 10 to the negative 5 and a higher dropout rate of 0.6. While for the self-attention, we had a more aggressive learning rate of 1 times 10 to the negative 3 and a lower dropout rate of 0.2, which we found stabilized the transformer layers. And we trained both models with a batch size of 128, early stopping of patients 10. And we also applied checkpointing based on validation accuracy. And basically this step ensured that both models had consistent training conditions. So here's the results for the 2 models. And as you can see, our self-attention model outperformed, consistently outperformed by RNN across all weighted metrics. Let's take the F1 score, for example. We can see it improved from 0.74 to 0.83 and so on. So based on the results, we can see that these improvements reflect how the self-attention model has the ability to capture long dependencies and long-range temporal patterns by focusing selectively on the most informative sensor feature. However, we did notice that notably for both models, the macro average scores are lower, which just highlights the common challenge in HAR, which is class imbalance, where rare activities like overlapping activities, let's say taking medication and also being in the kitchen cooking something else, can overlap. So while we know that the self-attention model performed better, it's also important to understand how the models behave during training. And this slide shows the specific training and validation curves for the bidirectional RNN. We could see, so we have accuracy on the left and loss on the right for both users. So the top would be user 1 and the bottom would be user 2. And we could see that for user 1, for accuracy, The conversions seems smooth with both accuracy and loss curves reaching around 85%. And there's also minimal gaps, which indicates there's no major overfitting and a stable learning process. And as for user 2, the training was also stable, but we might notice a little bit of a larger gap between training and validation accuracy, which might be a slight overfitting. However, it does continue to steadily decrease, which means the model is continuing to learn and hasn't plateaued prematurely. In general, this model did generalize well, and however, we could see that the performance does differ based on the user. As for the self-attention training and validation curves, we see a similar pattern, but we do notice for this model, it learns quicker than the BiRNN, which suggests better temporal and multimodal representation compared to the previous model because of the faster conversions and the higher accuracy. So now that we've looked at the results and their learning behavior of the two models, we can take a step back and compare them in terms of architecture and practical strengths. First, the self-attention model supports parallel processing, which makes it more scalable and efficient during training, especially when dealing with long sequences or high-dimensional sensor data. And in contrast to bidirectional RNN, which processes data sequentially, it can be lower and less scalable for larger or complex data sets. And secondly, we know that the self-attention allows the model to dynamically focus on the most relevant sensor feature at each time step, which makes it more robust to noise, to missing data, or even asynchronous sensor streams. And our bidirectional RNN, while capable of modeling temporal dependencies, it doesn't have a built-in mechanism to dynamically weigh the relevance of individual features per time step, which basically makes the self-attention better suited for complex multimodal human activity recognition tasks, like the one we had, especially in real houses with a variable sensor coverage and asynchronous input. And with that said, our bidirectional recurrent neural network remains valuable for interpretable temporal sequence modeling, but it may be outperformed in scalability and adaptability. So in conclusion, this study presented a novel privacy-conscious approach to human activity recognition using non-intrusive sensor data from our dataset SDHAR Home, which is a public dataset. And by integrating the appliance-level energy usage with ambient environmental sensors, we demonstrated that the smart plug data can serve as a valuable behavior signal, particularly for recognizing context-bound activities like watching TV or doing the laundry. And between the two architectures, we found that the self-attention model outperformed bidirectional RNN across all key metrics and also during training where it converges faster. And its ability to model long-range and asynchronous activity patterns makes it more suitable for the work that we do, like detecting humans within a household. And moving forward, we were exploring hybrid architectures which combine both temporal sensitivities of RNNs with the contextual power of self-attention or attention mechanisms. And we're also interested in integrating continuous energy disaggregation, as well as domain adaptation techniques to enhance generalization across households. And ultimately, our goal was to develop scalable, ethical, and trustworthy human activity home automation without compromising user parts. So this is it for me. Thank you.
So I'm interested in your sourcing of the data. In terms of non-human sensors or like wearable technology for the individuals, but if you're looking at the power patterns which give the same kind of profile about someone's activity, are you just using basically a proxy that would duplicate something like a sensor? How is it different?
It's different in terms of like using cameras. We don't actually use any cameras to view the person within a household or even AI that would view the person. We also did not use the wearable devices, so it wasn't intrusive in sense of physicality, like they didn't have to wear anything on them. And also, so we only relied on the environment in terms of temperature, light, infrared sensors to detect the activities they do within the household. Okay, you're welcome.
Question, are you using the same model for both users or like two different models for each user?
So we're using the same database, but two different models, and we compared the two different models. Oh, the users. No, we use the same, let's say the same bidirectional RNN for the first user as well as the second user. And the same self-attention for the first user with the second user. Any other questions?
It seems at this let's say the RNN is better than self-attention.
No, it was the self-attention was better.
Self-attention.
Yeah.
So, but if, I mean, let's see. I see. Sorry about that.
No, sorry. Yeah.
What I would like to ask is that if the number of types of research increase, then self-attention is much better than RNN or RNN is
the more sensors we have, the more accuracy we get, and I believe the self-attention will stay better than the RNN because of its power to focus on the like contextual feature instead of just doing the past and future sequencing, step-by-step sequencing.
Do you plan RNN or
self-attention. Yep.
Okay.
Yep. Thank you.
Yeah, that's it. Okay. Okay. Thank you very much.
Thank you.
Okay, everyone. So we have a lunch break. So after the lunch break, we have a keynote speaker from Toronto University, Professor Michael. So yeah, please over the end. Thank you for joining us. So let's join us for a keynote talk after lunch. Thank you.
Thank you. Thank you.
This is it.
in the discourse. I thought it's a study actually follow it.
Yeah, thank you. Thank you for having me.
Absolutely. I don't want to be universal. But there are real your study the successes.
Okay. Sounds cool. Also in the Joseph?
No. Yeah.
Oh, yes, hi, nice to meet you.
Nice to meet you.
Yes, nice to meet you. Yeah, I'm Brother Bears. My first time in this conference, also it's my hometown, so. Okay, great. Excellent. I was just visited your beautiful city a few months ago.
Oh,
yeah.
Actually, I was in Japan and Canada.
Yeah.
I visited there, so I was not here.
I know, actually.
Next time. He like Kyoto.
Oh, I love Japan, yeah. Yeah, when I was talking about my. Yeah, okay. Should I set up just to make sure it's so?
Yeah, we have.
I just want to make sure I'm a little bit nervous.
Yeah. If you want like to have the record, we have a Zoom.
Yeah,
So
okay.
you can connect to Zoom. So we have a record.
Sure.
Maybe it's like for like.
So do you want me to use this computer?
Yeah, I mean your computer. You just use a Zoom link to connect.
Sure.
Share your screen, so you can use it here.
I don't have all the.
Do you prefer that, or do you prefer me giving you the PowerPoint? Either is good for me.
Both one is.
These are just to be on your computer.
Because we are recording his talk, so maybe for future like.
Do you prefer it on my computer or your computer? Which one do you prefer? What's easier for you?
This computer is sharing it here. So if you connect through Zoom,
yeah,
you share your
okay, do you prefer
live
my
feed,
computer?
just like yeah.
Are you recording all the talks? No.
After yet, yes, but after the session, just like because of some presenters, they missed their flight. So that's why they asked me, they registered for this workshop. So that's why the flight.
I got an email from one of your one of your colleagues.
Yeah. So
and
the flight has been canceled. So that's why they registered for a workshop. So they wanted to attend. So that's why.
It will record the whole workshop.
Yeah. Not the whole. I mean, some like maybe the whole. I mean, like.
Okay. So
Zoom. Yeah. So we have a Zoom, right?
Yeah. So, and you want me to join your meeting?
Yeah.
So what's the
Zoom meeting?
Yeah.
This is the ID, the core code. Maybe I have no. I sent you Maybe I sent you. I sent you now.
I don't know.
What do you want?
Yeah, here.
We are near Chinatown, so there's a lot.
So this I will forward it to you.
So not the best choice.
Could you please check your email?
Okay. And I should look up the email that you sent me.
Yeah, I just sent you Gmail. Yeah.
Oh, you just sent it now?
Yeah.
Ah.
Yeah, it's a Zoom link. So you just connect this.
Okay.
Join.
We can do that. Oh, there's more.
Recording in progress. Just share. Could you please turn it on? Yeah.
Okay, I want to make sure.
Share.
The audio's off. Maybe it's because it's over here. Or maybe I go mute it, maybe.
Okay.
Maybe that's better.
Because we have the audio
Yeah,
here.
yeah.
So we share it?
I see what you want me to share. Okay.
Yes.
Allow. I think it'll be okay, but let me just see.
Yeah.
Present. Start from the beginning. Oops.
Yeah.
Okay.
Go to the Zoom. Just this one.
No,
This
that's
one.
no, that's Acrobat.
They close this one and then share again.
There we go.
Maybe you see this one.
No, that's Acrobat.
Acrobat.
Yeah, how do I? Here,
Very nice Polish.
so I'm sharing it.
He's here. Here, they said Google. It's as a Google.
Okay.
Is it Chrome?
It's Chrome, yeah.
Is it Chrome? Chrome, maybe this one.
No, that's Adobe.
Acrobat. This is Acrobat.
Yeah, I don't want Acrobat.
So this you want a Google, right? Google is this one.
Finder.
Google is this one.
No, that's Zoom, but let's see.
So
Cancel. No, it's not that.
The Google.
Here, let me go here. Here, let me stop sharing a second. Okay. Yeah,
This
maybe you
is
can
a
help here.
different.
So we're on Zoom,
Mhm.
and I want to share this screen,
where?
my Google Chrome page.
Okay, great.
So go here,
so you
share.
can do, you have to.
It's a different windows.
But it's extended. You just have to put this thing.
I see.
On this way, and after that you can
This one.
make a share.
Oh, here we go.
Yeah,
Okay,
here.
here.
It was different window.
Yeah, it
Yeah.
was.
Yeah,
Okay.
you- yeah.
Now it's good. Yeah,
Okay.
this one.
And now, but now what if I put
Just
present?
presenter view. Yeah. Yes, that's great.
Okay.
And then full make. Yeah, we will make it the. Okay. Yeah. Just try to make. Yeah. Now it's good.
Okay, perfect.
Perfect.
That works.
Yeah, I don't know if someone can talk, just make sure just sounds good.
Okay. Sounds good.
But at the
Could you-
Zoom, I don't know if someone like in the Zoom?
No,
Yeah,
it's
someone-
in person.
or
There's
just-
some people joining from Zoom.
But it's look, but my microphone, I turned
Just
off my
make sure we
microphone.
can hear that, but because you're doing with this
No,
laptop.
his microphone is here. I is here, so don't worry.
Okay, okay.
Yes, a talk will deliver.
Okay, as long as we're okay with that.
Are you coming for food?
Okay.
Okay.
If you have any question?
No, I think we'll figure it out.
Okay, great. Yeah, if any question, just, you know.
We're starting at 2.
Tag. Oh yeah, sorry, we're probably gonna have a tag. It's gonna be on the corridor at 30.
Okay, 1:30?
1:30, yeah.
Okay,
I
so I'm gonna be here like, 'cause we're starting at 2, maybe like a 10 to 2 or something?
Yeah.
Yeah?
1:30 is gonna be there.
Okay.
You can just scan the QR code on the people and someone.
Oh, I see. Okay, perfect. Okay, thank you so much. Okay. Is this door gonna be locked? Can I leave my computer?
Yeah.
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 Should I take my computer or should we lock it?
You can close the door.
Okay.
Yeah,
let's
you
close it.
take it your computer.
You want me to take it?
Yeah,
Just
do
in case?
take it.
Okay,
take
I'll
it.
take it just in case. All
And then
right.
you come. You have internet, Wi-Fi, right?
Yeah.
Yours or the venue Wi-Fi.
No, the venues.
That's great.
Yeah.
Okay, so you take your computer.
Okay, perfect.
And we'll be here. So I will also take my computer because like it's.
Yeah, I don't want
Thank
to
you
get
for
stolen.
joining. I mean, yeah.
it's cool.
Actually, our colleagues missed the flight.
I know.
Here,
it's too
Canada,
bad.
and my flight was the last flight
Uh,
from Japan to Canada.
Oh my
It
gosh.
was on August 15th.
Yeah.
Scheduled 6 o'clock p.m. And then they changed suddenly. They says, okay, and then make it 10 p.m. midnight. When I come here, Toronto, connecting flight, I missed.
Okay,
So the Air Canada facilitated and booked a hotel. So I stay one night in
I see.
Toronto.
I see. Okay.
Unintentionally. Then the next day, I used the Porter Airline
I
to
see.
come here.
Yeah, okay.
So I made it, but my other colleagues, they rebook another flight to United Airlines
Mhm.
through Canada,
Through
United
US,
States, and then come here.
Yeah.
I mean, and
Ah.
one of my colleagues, because he needs to apply for US visa. I mean, he just like
Yeah.
not preferred to come through US.
Sure, sure.
So that's why he will join us on August 20.
Yeah, he told me he's only gonna be August
Roughly,
20.
yeah.
Yeah.
Yeah, roughly.
Oh, that's
Yeah.
too bad.
Yeah.
Yeah. What can you do?
So that person, Takayuki, he's a lead professor.
Okay.
So we have many calls like yeah.